This conference will now be recorded.
Well, since I hope everyone is here and we have a lot to cover, we really should begin today's webinar, and I really appreciate you all for attending today's webinar.
Yes, perfect. You can start your presentation.
A very good morning, afternoon, or evening to one and all present here virtually with me today. Let me introduce myself. My name is Sharon Jacob, Conference Secretariat at Coalesce Research Group LLC, and I'll be available for any of your queries or questions throughout the webinar to help you out technically and organize the webinar successfully. For the next 5 minutes, please allow me to give a brief description about our organization, Coalesce Research Group, and also further instruction. Coalesce Research Group LLC is very delighted to welcome you all the speakers, supporting associations, students, and delegates present virtually with us today, with the aim mark the scientific excellence by facilitation, conversations, sharing knowledge. Coalesce Research Group follows through the objective of setting standards in delivering excellence in the research among the researchers, academicians, and industries, promulgating the research through conducting events and online webinars from various fields of science, especially from the stream of medicine, science, engineering, and technology. Within a short duration, we have succeeded in creating a platform for developing a strong professional network with the people across the world from their respective fields that they haven't connected in a while. As a global scientific event organizer, we plan and carry out international conferences, meetings, seminars, symposium, and workshops, providing the best delegate experience, excellent networking opportunities, conversations leading to innovations, learning new opportunities, lasting working relationships, and professionalization with the professionals around the global network. Just recently, we've also started our own platform for open access peer-reviewed scholarly literature, where all the content is freely available without any charge to the reader. We aim to share the new recent advances through scientific publications, which will help in minimizing the borders and contributing the use of research works of eminent authors, scientists, researchers, research scholars, students, etc across a broad spectrum of medical, clinical, pharma, and engineering scientific disciplines and its subspecialties to promote the ideas which will guide the development and facilitate the use of scientific information and ensure its quality, and also will be connecting link between researchers and scientific community. We are committed in ensuring that our journals are disseminated worldwide so that the researchers are able to access our content wherever and whenever they need it. As being the very new journals, we have coined up some interesting journals, and we have also formed the editorial board, and will be very glad if any of our today's attendees, the speakers, students, or delegates could extend your support by checking the journals and will be interested in publishing an inaugural issue at any of the journals according to your area of expertise. We will also send you an email with all the details about the journals after the commencement of the webinar, so do take your time to check the website. And finally, I would like to thank the attendees and participants of today's webinar and hope you enjoy the webinar and gain knowledge from the session today. We also hope your participation will contribute to new research findings and that will lead to new collaborations and research initiatives. Before we start with the sessions, I guess some of you will be new to the GoToMeetings app, so let me just give you a brief introduction about the important tools required for the presentation. On the GoToMeetings app on the web page in front of you, you can find when you move your cursor, you can find 4 icons at the bottom center, that is mic, camera, screen, and leave. So for the first one, that is mic, so you can click on that to mute or unmute. And I request you all to stay muted while our speakers are presenting the research work so that it doesn't cause any disturbance or distraction to them. And the second button will be the camera. You can use this button to share or unshare the camera webcam. So if you have the option to share the webcam, you can do it, and it's completely of your choice and there is no compulsion. And please be cautious if you have any network issue. I request you all to please turn off all your cameras as the camera with the network issue, it's impossible for you to connect with the camera. So the next option will be the screen. So you can use this button to share your screen. This is the main part during your presentations. After I call your name, from my side, I'll be making you the presenter, and when I give you the permission, you will be able to share your screen. So once I make you the presenter, you can click on the screen button and you will find the pop-up window asking your permission to share your screen. And the last button will be the leave. So you can use this button to leave this session. And on the top center, you can find the options to change your display settings. And at the top right corner, you will have three icons, that is people, chat, and settings. So in this chat option, you can chat with me or any other participants as per your requirement. And for the settings, you can use the other button at the last to check for the settings of your speakers, microphone, camera, and etc. So as mentioned, I kindly request you all to remain muted during the presentation of other researchers so that the presenters don't get disturbed, and for any questions you can ask them at the end of each session, or you can also message in the message box too. So well, let's not take much of your time, and I finally would like to request you, please give us a brief introduction about yourself before starting the session so that we can know about you virtually. And let's move on to our first session. So we have Dr. Sophie Hilaire from City University of Hong Kong. Let me just make you the presenter. Yes, I have made you the presenter. Please do click on the screen.
Can you see my presentation?
Actually, not yet. Maybe it might take some time. Yes, now we can see your presentation. Yes.
Okay. My name is Sophie St. Hilaire, and I'm a veterinary epidemiologist. I work on aquatic species, and I am currently working at the new veterinary college at City University of Hong Kong. So I've been working about the last 10 years on improving and reducing the use of antibiotics in aquaculture. And today I'm going to focus on issues that we've identified which have led to low dose exposure to microbes, particularly bacteria. So I'd like to acknowledge my graduate students and my colleagues who have contributed to some of the information that I'm going to share today with you. A number of us have been working on this topic for some time now. Sorry, my mouse isn't working, so. All right. Most agricultural sectors have been under pressure for improving antibiotic practices in the last 20 years or so. And aquaculture is not exemption from this. In the last decade, there's actually been several reports of emergence of antibiotic resistance in aquaculture systems, which is driving some of this pressure that the veterinary community is under to reevaluate their antibiotic practices. In Hong Kong, which is where I'm located currently, I've summarized, we've seen some concerning trends as well. And I operate a small veterinary service for aquaculture farmers here. And so we've been monitoring some of the isolates that we find in both fresh and saltwater aquaculture. I've summarized 32 isolates from our practice by their sensitivity and resistance patterns. And the color coding on this slide is just to show different regions. But as you can see, most of these, so these are either Vibrios, Aeromonas, or Streptococcus species. And as you can see, most of the isolates have at least 2, if not more, are at least have 2 antibiotics where they're resistant to, or more, in some cases 7. And so the take-home message here is that we do see antibiotic resistance in these aquaculture pathogens. So how did we get here? Well, there are a number of ways that bacteria can be exposed to antibiotics and develop antimicrobial resistance. But I'd like to focus on veterinary medical practices that may be driving some of this resistance. And two practices in particular that are of concern are overuse of drugs and underdosing of antibiotics. And underdosing is what I'm going to focus this presentation on. And it occurs probably because of a number of reasons. And that's what I'm going to discuss in the next slides. So first, it's important to understand how fish are treated when they're treated with an antibiotic. So if you have a population of fish and they're sick with a bacterial disease, then often we will prescribe an antibiotic to treat those animals, and we'll coat the feed with the antibiotic at a dose that we that is deemed satisfactory for whatever pathogen we're treating. And the way that we figure the dose out is we take an average weight of the fish in the population, and we assume a certain percent of their weight is being consumed evenly across the population. So ideally, what we want to see is that the population of fish that you're treating is over that limit, that threshold limit that is required to effectively treat fish, and that they're not too far out, so some animals are not over-treated. So please, if I'm not clear, someone can send me a message because I'm not seeing the audience very well here. So my grad students and I, several years ago, decided to look to see whether metaphylactic treatments, which is what we call these treatments that you're treating an entire population of animals, regardless of whether they're infected or not at the time of treatment. We wanted to see whether or not we had this distribution where the majority of fish after the treatment were effectively treated. And so we looked at a number of salmon farms that were treating for a bacterial disease called Picerichetsia salmonis in Chile. And what we found was that, and we looked at the 2 antibiotics that are commonly used in aquaculture, which are fluoromphenicol and oxytetracycline. What we found was that there was a very high percentage, especially with fluoromphenicol, of animals that never attained that therapeutic threshold on the last treatment day. For oxytetracycline, if we used a 1,000 ppb concentration as the therapeutic dose, which is a bit low probably, we had a little bit better success. But if we moved it up to 2,000, which is probably more normal today, we would have almost as high of a percentage of the population that were undertreated. We also had these fish out here that were that had very high levels. So some fish were clearly eating way more than their counterparts were eating. So why do we have such a high percentage of fish with low levels of antibiotics in them after a treatment? Well, this probably happens for a number of reasons. So it's not just one factor, unfortunately. It probably has to do with dosing of the fish and of how we apply the drugs to the population of a large population of animals altogether. So I'm going to go over some of the issues that we've identified over the last few years. First, we purchased a number of antibiotics, both chloramphenicol and oxytet, those two commonly used drugs, from the market to see whether or not the products were as high concentration of antibiotics as stated on the label. And what we found, we bought 16, we purchased 16 products from different companies, and we tested them at several labs, one being a government lab. And we found that over 50% of the products that we purchased were below 75% of what the label said they should have been. So that means that when you're using these products and you're basing your prescription and your dosing on the label, you are underestimating the amount of product that's actually in the feed, the medicated product that you're using to top coat your feed. So, and in fact, some of the products that we looked at registered 0. So there are a number of fraudulent products out there, and they are probably causing some problems with low dosing. The other thing that we have to deal with is that a lot of these products are perhaps slightly less expensive on the market than the high quality products. And so they are very attractive to farmers and to users. The result is likely an underdosing, and it's probably proportional to the amount of drug that's not accurate from the label. The second issue that we've encountered is environmental leaching of medicated feed. So when we top coat the antibiotic on the feed, we also usually put a small oil layer on top to try to keep it on the pellet, and we expect the fish to eat it right away. If the fish does not eat it right away, then that medication eventually disperses in the water. And so we looked at, and this is fairly preliminary data, however, there are some other articles that have been published on this in the past. So we looked at a couple of our farms in tanks, and we measured antibiotic levels during the treatment, so when the fish are fairly actively consuming the product, and about 30 minutes after. And we did find, on all occasions, we found antibiotics in the water column, and we even found it 30 minutes after. However, it was quite a bit lower in the water column at that point. But the point is that not all the feed, not all the medication is going into the feed, into the fish when they're consuming that, that pellet. So the consequence of this is that you're going to have you're not going to dose accurately what you want the fish to have. And if it's so the drug concentration in the medicated feed is going to be inadequate to achieve the therapeutic dose if all the fish are evenly consuming the product. That brings me to the next issue that we have. So in addition to the dosing issue, you also have a problem with uneven consumption of medicated feed within a fish population. So this happens because there is, most fish species develop a hierarchical structure within the tank or the pens. And so if so some fish will dominate and feed more or increase their percent body weight consumption per day versus other fish. And in addition to that, when the fish get sick, those fish tend to eat less. So they'll either go off feed completely or they'll just consume less product. Which, remember, when we're dosing in a metaphylactic manner, we just dose on an average weight and we assume that all of them get a certain percentage of food that is proportional to their body weight. So the consequence of uneven treatment in a population is that some fish will not achieve the therapeutic concentration of antibiotics. And that subpopulation of animals remains infected. So if they survive beyond the treatment period, then they can be a source for reinfection of the population. So that isn't good for the farmer. And we wanted to see how problematic that was. So we actually did this study using emamectin benzoate, which is an antiparasitic drug for sea lice. But because sea lice is closely monitored, so you can evaluate whether you get reinfection during different periods after your treatment, it facilitates the assessment of reinfection during the clearance period that fish undergo after the treatment has subsided. So after you've completed your treatment, there's a certain period of time that fish will metabolize and eliminate the product. And that period of time, so for emamectin, it depends on the temperature, of course, but we've got this window where if fish get infected with parasite, the parasite is actually exposed to a low dose of medication, which we know from other studies can be problematic for increasing the risk of antimicrobial resistance, or AMR. And this happens with bacterial treatments as well. So the consequence of reinfection post-treatment is that the fish, the pathogens are exposed to this low dose of or sublethal levels of antimicrobials, and that actually can trigger or potentially increase the risk of developing AMR. And if it was one fish, it wouldn't be so bad, but some of these farms have millions of fish on them, so you're getting some pressure there for AMR resistance. And remember, I had just spoken about how if you're not properly treating your fish because they either didn't get the right dose or they didn't eat enough feed to get the right dose, you can have these persistent infections within your population. The other potential consequence of this low dose or this clearance period where the fish has therapeutic levels of antimicrobials is that the normal flora of the animal can also be exposed to low dose of antibiotics, again, increasing the risk of AMR. So what can we do to address these issues? Is there anything that we can do to address these issues? And I think the answer to this is there are things that we can do, but I don't know if it's enough, to be honest. So I'd like to just finish with a few ideas on how to reduce the impact of these issues I've highlighted. So first, I think it's really important to recognize that prevention of disease is, so that no treatment is required, is probably the only way that we are going to avoid the use of antibiotics and the selection for antimicrobial resistance. So it's important to realize that there needs to be more research and innovations for disease prevention to enable farmers to raise their fish without having bacterial outbreaks. And that includes things like vaccines, immunostimulants, probiotics, phage therapy, technologies to look at cleaning water, and other things that are even more on the experimental side of things. But promoting this sort of advancement is necessary. However, given that we are intensifying aquaculture systems all the time around the world, it's unlikely that farmers will be able to avoid all bacterial outbreaks. So in the event that they do have to treat, then it is really essential to pay attention to reducing this underdosing phenomena. And first, I guess the first thing to start with is to use quality assured products, even if they are more expensive. That will increase the chances that more of the fish get the proper dose. Also, there are some medications that leach worse than others, and there are some top coating materials that are better. So certain oils are better, and depending on the temperature that you're farming at. Also, there are some gelatin-based, pectin-based types of feed coatings that might be more effective for increasing or decreasing the leaching of these products. And it might be specifically or particularly more important to do that with species that take a long time to feed. So for example, shrimp might take a bit longer to eat the pellets given to them than a rainbow trout that would devour it as soon as it hits the water. So these are things to pay attention to. Then ensuring that your feeding practice is resulting in an even feeding within the population. So to do that, there's a couple of things that farmers and fish health professionals should be thinking about. One of them is to treat early. So the earlier you treat, the fewer of the fish are infected. So you're more likely to reduce that outbreak. You're also more likely to have more fish that are on feed. So it takes a while before they go off feed if they're sick. So the earlier you treat, the fewer of those are going to be there. It also reduces the number of chronic infections in the population, which those fish obviously don't eat very well, but they also have sometimes pockets of infection that are hidden in tissues that are really hard to get at because you've got tissue reaction around the bacteria, or the bacteria has found its way in an organ that is more difficult to treat, for example, the brain. And then in addition to treating early, using appropriate feeding strategies. So there are ways to reduce that hierarchical behavior in fish populations. If you have a farmer that has a very wide range of weights within his pen or his pond or tank, then the feeding isn't evenly distributed. So you can usually increasing the frequency of feeds will and ensuring that the feed is spread out throughout the entire surface area of the tank or pond will help that. There's also in the salmon industry, they've started doing just constant feeding or micro feeding, I believe it's called, where that seems to be helping with the more even distribution of the feed within the population, so that those fish can actually get the drugs that they need every day to keep and maintain the therapeutic level for the period of time that's required to treat the bacterial infections. And then preventing that reinfection during the critical period where the fish are eliminating the drugs in the after the treatment has subsided. So that means treating the population long enough for all of the animals to have effectively been treated. and if the fish aren't eating, then culling those or removing them from the population so they don't serve as a source of infection once the treatment is completed. The other source of infection for many of these open net pens and farms that share water sources are neighboring farms. So if you're in an area where your neighbors are very close, then coordinating with your neighbors to ensure that if they're also infected, the treatments are done synchronized so that you don't ping pong back and forth these bacterial pathogens within the population. So I'm going to end here, and I hope that this presentation has highlighted some of the issues that some of these aquaculture industries are facing in terms of treating with antibiotics and some of the potential solutions that could at least reduce the impact of this low dose exposure to to microbes. And I'm not sure I'll take questions.
Thank you very much, Dr. Sophie. So any queries?
Thank you, Dr. Sophia, for your presentation.
Amit Sharma. Main meeting controls. Next call. Attend this chat. See who's joined, send a message, set your camera, audio preferences here. এই যে এটার মধ্যে ক্লিক করলে তুমি অডিও প্রেফারেন্স শুনবে, কি মিউট করবে, কি করবে, কারা কারা জয়েন করলো, মানে এখানে আপাতত 11 জন পার্টিসিপেন্টস আছে।
Dr. Anupam, please mute your audio.
Yeah. On to our next presenter is from Dr. Anna Fetch.
Got it, go. এটা মিউট করো।
এটা
হ্যাঁ।
Well, I don't think there's any questions, so I'll pass it on to the next speaker.
Okay. Thank you for the confirmation.
No, it's
So
not
next
visible.
presentation by Dr. Nguyen Yu Hao from Imperial and Motive Products, Cargill Inc., Vietnam, and the presentation title is Motive, a bioactive protein ingredient designed for shrimp industry.
Button. Yes. Is it asking for any permission?
Dr. Ho, you can share your screen now.
Then only you
Yes, we can see your screen. Dr. Ho, we can't hear you.
is it showing that you are share my screen so that you can Okay.
Sorry, I
I'm so
cannot
sorry.
hear you.
I'm so sorry for disturbing your presentation. Yes, we are not able to hear you well. Could you please check your microphone settings?
Yeah, hello. But your screen is not visible to us, Dr. Ann. Okay, you can do one thing. Can you please share send your presentation to Sophie?
Uh, Dr. Guren, please do try checking your settings, audio settings, or try to disconnect your headphones and talk. Because at the beginning, we could hear your voice, like at the starting when you spoke with me, that was clear. So try disconnecting your headphones and reconnecting it once again.
Hello, can you hear me
Yes,
now?
now, yes, perfect. Please do continue. Please do start your presentation now from the beginning. Thank you.
Okay, sorry.
Yes, you can share the screen now.
Yeah, but the share button doesn't work. Can you assign me the sharing? Okay. Okay. Can you see my screen?
That's
Hello.
perfect. Yes,
Okay.
we can see your screen.
Sorry.
We can see your screen. You can start.
Okay. So today's my talk is we'll introduce you the multiple bioactive protein ingredient decided for shrimp feed industry. And here's the agenda of my talk. So first introduction that you know that sustainable shrimp farming technology not only require developing the sustainable farming technology, but also the fish meal alternative for the feed industry. And today is a lot of products like insect meal or microbiome also in the testing step and waiting for the launching. And with that approach, Cargill also innovated and developed with a bioactive protein ingredient namely the motif, and we start launching now. Now I introduce you why we have this product. First, we understand the shrimp feed production before we develop this project. So, shrimp feed production is a quality consistency is a very important, and that depend on the feed production technology like particle size, cooking temperature, retention time, and so on. And also the raw material, high quality raw material, especially very high digestible, adaptant, palatability, and healthy. And here's a common raw material in the shrimp feed. Mostly is focused on the health nutrient that mainly come from the fermented protein, like fermented corn protein. We have developed it as a motif, or lactobacillus fermented soy, inactivate protein meal, or marine algae, herbal extract, or insect meal. With those fermented protein or inactivate, you can provide health nutrient like biopeptide, organic acid, nucleotide, carotenoid, or bacteriocin. Also, other health additive like vitamin and vitamin and very key important for the shrimp, and it play because it involved in a lot of health function, and mostly it coming from the fermented foods. That's why we do the fermentation of the corn protein to get the motif product. Biopeptides has several health function, health promoting effect like blood cholesterol control, improve cardiovascular system, boost immune system, or improve digestive system, or even antimicrobial peptide can play as an alternative to antibiotic in the animal, livestock, or in aqua. Organic acid also the second nutrient is very important for health. It's because it can inhibit the pathogen, improve the mineral utilization, and it also can increase the pepsin activity, or at the end the protein digestibility. Also, some of the study already showed here with organic acid and essential oil can fight against Vibrio parahemolytic good, one of the pathogen causing the early mortality for the shrimp. Or other bacteriocin produced from lactobacillus can also kill the free spore of microsporidium and eliminate that spore. And in the shrimp, the EHB is one of the microsporidium disease, very drastic to the shrimp industry. Also, some of the amino acids play as a health nutrient like glutamine that can secrete of the immunoglobulin. So, in the shrimp, especially the white shrimp, indoor culture at high stocking density, they found that the glutamine is required very high for vannamei compared to other shrimp. Also, leucine also one of the amino acid play in terms of health, but you need to provide through the protein binding or through the raw material. So supplemental leucine doesn't work very well. Also, this is one of the famous professor in the Taiwan University, and he has a lot of study on carotenoid. It's a very important for the shrimp also. Carotenoid play the stress resistant to physical, chemical, and bacteriological stresses, and it can be a strong antioxidant compared 20 times compared to vitamin E. Nucleotide also one of the strong stress resistant for the shrimp, and you can see the some of studies show here the supplemental diet with supplement with nucleotide is a better weight gain compared to the control without the nucleotide, or increase the hemocyte count in the hemolymph, so it can bring the improve the immunostimulant. Vitamin and mineral, of course, play very important in health, nutrient for all animal, including the shrimp. And here you can see the study shows 35% protein complete with the mineral and vitamin, and 35 protein diet but less mineral, 30 protein diet with complete vitamin and mineral. And you can see, especially even you have higher protein, 35 protein, it will be lower performance than 25 protein, but complete the vitamin. So all between the pond culture and well water, clear water also different. So in the natural food in pond also provide mineral and other nutrients that can help the shrimp grow better, especially the vitamin C, vitamin E, vitamin A, and vitamin D3 is a very important for the shrimp health. Not only understanding the shrimp nutrient requirement and health nutrient for shrimp, we also try to investigate the shrimp dietary system before we develop the multi product. So you can see here, the shrimp also very primitive animal, but they also have the foregut, midgut, and hindgut. In the foregut, the stomach, they have the cardiac stomach and biliary stomach that connected to the intestine and hepatopancreas, and with through the filtration, and that can add in the but in mainly in the hepatopancreas is a enzyme is located there to digest the nutrient before bumping the digestive nutrient back to the intestine for absorption. Uh, uh, for midgut, it's mostly for the absorption. For the stomach, is breaking down enzyme there, breaking down the nutrient in the small part. So that's why the filtration back through the biliary stomach into the hepatopancreas very important, because it go through the gut tube shape, and that allow only a very small particle below 1 micron can enter into the hepatopancreas. Understanding mechanism, physiology of the shrimp in the digestive system of the shrimp, we develop the product by fermentation to cut down the soluble protein into very short peptide, so that they can enter in the hepatopancreas to support the health, because hepatopancreas is the key body of the shrimp in terms of the health and in terms of the digestion. So that's why we developed the multi-product by fermentation of the corn protein through lactobacillus, using lactobacillus to produce a biopeptide, because it can help with the fermentation that can allow the microorganism to break down the protein into short peptide. And after fermentation with lactobacillus, we have the mainly the peptide fraction and the lactic acid 7.2% lactic acid in the product, and 3.5% peptide below 10,000 kilodalton, or 3.1% peptide biopeptide below 1,000 kilodalton. We also have very high carotenoid, 285 ppm. So with that this is the nutrient multiple. You can see also those glutamine or leucine I mentioned for health, 8% glutamine or 10.3% glutamine. We also have the 7.2 organic acid. So in general, multiple has a high protein and very low carbohydrate. If you compare to hydrolyzed soy or fermented soy, it's 23 to 24 percent carbohydrate, but we have only 1.7, very pure protein, and we have very low fiber. We have 7.2 lactic acid, and 5.3% is a peptide below 10,000 kilodalton, or 3.1% below 1,000 kilodalton, and we have no anti-nutrient, very high digestible phosphorus also. And also amino acid very high digestible, minimum 85 up to 97 digestibility of amino acid. So so that's why we have the multip is mainly the consist of the health nutrient. So according to WHO et al. 2019, how we control the vibro and stress resistant, that we can use a natural product or metabolite health nutrient that can squeeze the pathogen in the gut into the beneficial bacteria. And these health nutrient can help, for example, organic acid can inhibit the lower the pH to inhibit the vibrio, or peptide can do the same. Nucleotide increase the stress. Glutamine and leucine, I show you the study already. Carotenoid also very strong antioxidant and stress resistant for the shrimp. So we have all those health nutrients to switch the to favorable for the beneficial bacteria in the gut. And with that, we produce fermented to cut out the peptide into cut out the protein amino acid into biopeptide to optimize hepatopancreas. So that owns the multi-product I introduce you. Now I come to trial and research. We have the first trial. We compare the the fermented corn protein with embryo 75 that non-fermented, that the control diet, and we also added the control diet with lactic acid to have the same in the multi diet. Or we have 3 times lactic acid to see at low lactic acid adding and high lactic acid adding, how does it work. We also have the replace feed meal at 6%, 9%, 12%, and with 300 shrimp per square meter. But and in Taiwan, we also have the same trial, but only 80 shrimp per square meter. And here the result, you can see the multi diet is a significant weight gain, 19% weight gain higher than the control, or the control adding the same lactic acid, or control adding 3 times lactic acid. Or in FCR also we have lower FCR, 16.3% lower FCR compared to the control, or control adding the lactic acid. When you add too much lactic acid, it also not good. In the replace feed meal at 6%, 9%, 12%, at high stocking density 300 shrimp per square meter, we have significantly higher survival rate compared to the control. Why at 80 shrimp per square meter, we have no significant difference in terms of weight gain, FCR, or survival. So it means the motive very strong in the stress resistant. We also challenge that and with the pathogen EMS on the shrimp, and we see the significant higher survival compared to the both city control. So it means it can help to fight in the pathogen, EMS pathogen. Then we do the commercial in Vietnam trial. We use a 7.5 motif to replace the 7.5 feed meal, and we use commercial control diet as a control diet, and diet 2 we add in the 50 ppm of astaxanthin to compare with the motif diet, add in only 25 ppm astaxanthin, and this diet only 7.5 motif replace 7.5 feed meal without astaxanthin added. And we do the first diet tour that for we fit on the 500 cubic meter tank, 250 square meter for 2 diet. And the 4 diet we have 12 tank with 3 replicate for 1 diet in the indoor. And we have 2 pond to fed on the diet 1 and diet 3. And you can see here in the side one 200 2 tank 500 cubic meter, you can see the motif adding the astaxanthin much better than ADG, lower FCR compared to the diet 2 that the control diet adding astaxanthin. We have better score, color score also. So 7.5 motif plus 25 ppm astaxanthin result in better red color score than the control diet adding 50 ppm astaxanthin. Other also we have the motif diets on diet 2 also the trial with 12 tongue 3 replicate for one diet. We have no significant difference in weight gain, a little bit lower FCR in multi diet compared to the control with and without astaxanthin. We have much better, significant higher survival rates compared to the control with and without astaxanthin. Also better color score. For inborn, diet 1 is a control diet, was infected by ESB at day 37. So we stop that one. The multi diet still continue and harvest at day 60. So here you can see the multi diet 7.5 multi and adding 25 bbm astaxanthin, the red color, much better the control diet adding double astaxanthin 50 bbm. We also do another commercial trial. We have 2 bond motif, stocking density almost the same compared to the control bond. Here's a motif diet formulation and control diet. It almost similar nutrient. And here you can see the FCR also smaller in motif, 2 bond motif, and although the big it get bigger size and lower FCR, better ADG compared to the control diets. We also count the hemolymph in the hemolymph also. We have the better higher hyacinth cell or higher hemocyte cell compared to the control. So multi also improve immunity. In terms of color, we also boil the shrimp and measure the color after 40 days and after 60 days fed on multi. And we have the 1.5 color score higher. Here's a 25.5 and here's a control only 24. So we have 1.5 color score higher in the multi diet. In terms of the profit return on cost, we have better profit return on cost investment in multi-bond, 2 multi-bond compared to the control. And then we have trial in Indonesia. We use a multi combined with krill meal to replace the fish meal, or replace both fish meal and bone meal, or replace directly multi replace bone tree byproduct meal. And here you can see significant higher weight gain when we combine 7.5 multi and 1.5 krill to replace 9% feed meal, barrel feed meal, or 7.5 multi replace direct 1 by 1, able by able, 7.5 bone tree meal. We have better significant higher than the control. We also measure the lysozyme, and you see lysozyme is significant higher than the control in all multi diets. So multi promotes antibacterial response because enzyme lysozyme is related to antibacterial response. We also count bacteria in the hepatopancreas, and we see significant lower the bacteria count in hepatopancreas compared to the shrimp fed on the control. We also do the stress test from high salinity to 0 salinity at 1 hour and at 2 hours, and we see the significant lower mortality in the multi diet compared to the control at both 1 hour and at both 2 hours. So multi increase the stress resistance. And then we do the trial with different trial in the with the feed mill, big feed mill here in Vietnam, in the RAP system, 8 week and start from 1 gram, 4 replicate for each diet. And first we replace the barrel feed mill, 2.5, 7.5, 12.5, and 7.5 but balanced with cholesterol to compare 7.5 without cholesterol balance. and balance fish oil, and you can see final weight, FCR, and survival rate not significant different. Only the one that balance cholesterol have lower performance. And then we do also did trial on monodon, but we use a vanillin feed, and we replace feed meal by 5, 10, 15% of multi and 10% multi with balanced cholesterol to replace the barrel feed meal also. And with this, you see the when we use a monodon feed balanced cholesterol, it doesn't work. But when we use a vanillin feed and balanced cholesterol, it we have final way, FCR and survival rate, all the treatment the same. So it means multi can replace with or without cholesterol balance also good, and can replace up to 15% multi can replace 15% barrel feed meal. And then we do another trial. We use a 4.8% and 9.6% multi to replace the feed meal, also barrel feed meal. And you can see FCR, final weight, or survival rate also almost similar. And another treatment trial that we use 3.85 and 7.7% multi to replace the local feed meal, not replace feed meal, barrel feed meal. And we also have the same similar final weight, similar FCR, and similar survival. Very comparable for fish meal alternative. 3.88, 5.8, and then we do 7.76%, and multi to replace the feed meal. And then we also balance with cholesterol balance and fish oil balance to balance the lipid. And also you see the final weight, or FCR is almost the same, similar. So multi is a very good to replace the fish meal for both monodon and vaname up to 15% replacement. So for the conclusion, through different trial and result, we can conclude that first, motive is improve the coloration at minimum 7.5% motive. It can bring up 12% of color improvement. And we recommend inclusion using motive in the shrimp feeds at 7.5 to 15%. And in terms of survival related to environmental stress or healthy gut, it can bring up the 4% survival rate. Or in terms of the production performance, it can bring up the weight gain 5% or reduce FCR at 5%. Thank you very much, and sorry that I have the trouble with my voice, my setting up audio. Thank you. Hello. Hello.
Hello, thank you very much, Dr. Nguyen Du Hoa. So, any queries? Okay, I hope that there are no queries. So, next presentation by Dr. Priyanka Mukherjee from University of Calcutta, India. And the presentation title is Effect of Processed Green Algal Diet on Fish Immunity.
Okay, good evening, everybody. Good morning to all of you. Sharon, can you please? Okay, can I share my screen?
Yes, you can share now. I have made you the presenter. Yes, we are able to see your screen.
Yeah, right. I'll just maximize it. Just a moment.
Okay.
Okay, so I think it is maximized.
It is clearly
Okay,
visible.
hello everybody. Okay, thank you so much. Hello everybody, myself, I'm Dr. Priyanka Mukherjee from the Department of Botany, University of Calcutta, and I have been working with application of algae as fish diet for 7 to 8 years. And I really want to thank third online international conference on aquaculture and fisheries to provide me with this platform where I can share with you all my views. So I'm going to start it now. My topic is effect of processed green algal diet on fish immunity. Now, as we all know, aquaculture, aqua farming, this particular field is a huge field, and it basically extends from rearing of freshwater and saltwater populations of different aquatic organisms, whether it is aquatic plant to molasses, and then aquatic like fishes and different form of fishes like edible fishes and ornamental fishes. I'm just having a bit technical error, so just bear with me. Just shift it away. And under controlled environmental condition. Now, it was first initiated in Australia by Gunditjmara people in Victoria, where they converted several like kilometers of volcanic floodplains in the vicinity of Lake Condo into complex channels where they could capture eels and other fishes and preserve them to be eaten all year round. Okay, now as we are more concerned, as India is more concerned with fish aquaculture, because we know that maximum of the trade or Indian economy majorly depends upon fish aquaculture. Basically, two types of fish aquaculture are practiced here. One is the farming of edible fishes, and the other one is the farming of the ornamental fishes. So we have a good collection of edible fish farming as well as ornamental fish farming, and studies have revealed that about 65% of the exports basically come from Asia, and that is from India. And therefore, the industry of colored fishes today in India has gained a lot of importance. Basically, in India or in maximum part of the world, two types of ornamental fishes are reared. One is the exotic ornamental fish, and the other one is the native fish. And we almost have 288 exotic varieties that are currently raised in India, as well as 200 native species of fishes are being reared, or freshwater fishes are being reared in different parts of India, and they're entering into world's market. Now, these are the some of the pictorial representations of the different types of ornamental fishes that are being domesticated throughout the world. Basically, my work has remained, in this particular presentation, I would be showing application of algae as feed or as diet for colored fishes. But I had been working with edible fishes also. But today, I would be concentrating only on application of algal feed in ornamental fishes. So therefore, I am elaborating on this topic. So these are the different types of the ornamental fishes that are domesticated throughout the world. These are the common ones. So now we find, or we see, brilliant coloration of fishes. Now we need to know that where does this brilliant colorations come from? Basically, the skin colorations that determine the quality of the fish. It not only in the world's market, it is the most important factor on which the price as well as the domestication purposes of the fish depends. Now, but this not only adds up to the aesthetic value, but the fish uses this color for signaling purposes during courtship, mating, and camouflage. But the problem that fish faces are that fish cannot synthesize colors, or colored fishes cannot synthesize their own colors. They depend upon the diet or the pigments that are being supplied to them through the diets. And these pigments which are responsible for the colorations are porphyrin, pteridins, melanins, and carotenoid. Now, the carotenoids, which are basically supplied through the feed, they can be in the form of lutein, zeaxanthin, astaxanthin, beta-carotene, whatever. They basically enters into the cellular system of the particular cells and of the fish. And then these carotenoids get esterified into esterified forms of carotenoids. Now, once they are esterified, a part of them acts as integumentary carotenoids, and they impart brilliant coloration or brilliant skin coloration to the fishes. Actually, these integumentary carotenoids get stored within specialized cells present beneath the scales of the fish, which are known as the chromatophores. And the other part of the esterified carotenoids, they enter into the liver through certain lipoprotein channels, and they increase the growth, the reproductive efficiency, as well as immunity. Now, there are certain major constraints of aqua farming that are currently being faced by the aqua farming or the aquaculture based farms in India, and especially in West Bengal. The things are that one is the high price of the market available commercial feed. Over here, whatever commercial feed are present, they are very costly, and as we all know that India, the fish farmers are not very rich here. So or maximum of the there are certain people who belong to the below poverty level, so they cannot afford to buy that commercial feed. Even if they buy that commercial feed, these commercial feed has certain, or they have certain detrimental effects of the synthetic pigments when they are incorporated within the fishes, and therefore this act as the health of the fish or their lifespan decreases. And another detrimental or a constraint of using commercial feed is that this commercial feed usually spoils the quality of the water, therefore making the fishes becoming more susceptible to various fungal and bacterial diseases. Therefore, from that particular concept, basically several researches have been done throughout the world, and it is being done till date, replacing commercial feed with a suitable replacing agent, which can. So, in our study, we basically carried out what we carried out. We tried to replace algae, replace commercial feed with algae. So, this is a pictorial representation showing that whether can algae replace commercial feed, and the other fish is saying yes, it can, and surely it will. So why are we using algae to replace the commercial feed? First of all, algae can grow in wide ranges of habitat. It is cosmopolitan in nature, and wherever you don't need to go to some place to find algae, you can find it everywhere, whichever way you look at. So, and the worldwide annual production of algae has been estimated to be approximately more than 5 million kg per year. Then chemically, and most importantly, that is the reason why we are using algae. Chemically, these algae are beautiful and rich sources of various nutritional parameters such as protein, carbohydrates, fats, lipids, pigments, amino acids, vitamins, and minerals. So they are rich bioactive substance sources. Now, the application of algae in aquaculture and animal feed requires certain strategies or certain steps to be carried out. For example, processing and formulation. And then these algae-based feed can be used not only in aquaculture, but they can also be used in bird rearing and in animal husbandry. Now, in my study, in this particular study, what we have done, we have used chlorophycean members for making fish feed. Now, chlorophyceae or green algae, as we all know, they are cosmopolitan in nature, and they can grow, or they are they can widely grow in different marine as well as freshwater habitat, and they have a good or marked content of chlorophyll A and B. Then green algae are hubs of several bioactive compounds like phenols, flavonols, pigments, which can be alpha carotene, beta carotene, lutein, astaxanthin, and they have sulfated polysaccharide as well as vitamin contents, and therefore this has made chlorophyceae to find a profound usage in the nutraceutical industries. Furthermore, it has been studies have shown that when nutrient stresses are usually applied to algal cells, not only in algal cells, even in human cases also, in any type of cells, if nutrient stresses are usually applied, this basically leads to the rapid formation of the reactive oxygen species and reactive nitrogen species within the cells. Now, to strive this ROS and RNS condition, the cells themselves, they start overproducing several bioactive compounds, such as different polyphenols and flavonoids. And what they do, these bioactive compounds helps to scavenge out the reactive oxygen species and reactive nitrogen species, and therefore makes the cell or helps the cell to strive through such stressful conditions. So these upregulated compounds, now if we can if similar things or similar mechanism works out in case of algal cells too. So if we can basically utilize this upregulated compounds, we can extract these compounds, or as in we can use this algae as directly as feed, they can attribute to a potential aquaculture, or they can form potential aquaculture based feeds, as well as they can be used in other pharmaceuticals and nutraceutical aspects. Now, Sundarbans, we are well aware that Sundarbans, the deltaic region of West Bengal, is basically which extends from north to south 24 Parganas. This is the Sundarban deltaic region of Sundarban, is basically the hub of different algal combinations, but green algae are rich, or this particular area is rich in green algal genera, and number of different algae can be found over here. So these were the different sampling sites that were that were studied for screening of different, or for sampling of different algal or green algal genera from the Sundarban region. These are the algal ponds of Sundarbans where we carried out our work. Now, after screening programs and after sampling large number of sampling sites of Sundarbans, 4 profoundly grown chlorophycean members of Sundarbans were selected for experimentation. They were Chaetomorpha area, Cladophora glomerata, Pithophora claviana, and Rhizoclonium crassipulatum. And these are the pictorial representations of the aforesaid algae. Now, they were maintained in the culture collection unit of Department of Botany, University of Calcutta, and mass production was basically done. And after the mass production, basically, the antioxidant study of the algal genera, selected algal genera, were carried out, and 2 sets were taken. One was the controlled biomass, and the other one was the stressed exposed biomass, where the biomass were exposed to nitrate stress as well as salinity stress, and both the biomass were maintained for 21 days, and at an interval of 7 days, basically the extract preparations were done. Methanolic extracts were selected on the basis of yield of polyphenol contents, and the parameters that were studied were growth in terms of chlorophyll, total phenol content, total flavonoid content, carotenoid content, DPPH radical scavenging activity, and ferrocyan chelating activity. Now, from the studies that we carry, this initial study was to see whether there was any elevation or there was any upregulation of the polyphenolic contents or of the carotenoid contents of algae in response to the different stresses. And we were successful in this particular experimentation, where we found that the chlorophyll content was a maximum in case of the 7 days control setup, followed by and these were the data for the different chlorophyll content of the four different genera that were selected, and the similar trend followed. That is, in the case of controlled setup, we found maximum amount of chlorophyll. Now, in case of polyphenolic contents, we found that nitrate stress of 1500 ppm nitrate on the 7th day led to the maximum yield of total phenols, and this type of trend was followed for all the 4 genera that were studied: Rhizoclonium, Pithophora, Cladophora, and Chitomorpha. Now, in case of flavonoids, we found that 1500 ppm of NaCl showed maximum amount of yield of the flavonoid contents. And then the carotenoid contents were also found to be maximum in case of the 7th day algae exposed to 1500 ppm of 750 ppm of nitrate. And we found that maximum amount of DPPH scavenging and ferrocyan scavenging activity in case of the algae that were exposed to 1500 ppm of nitrate on the 7th day, as well as 1500 ppm NaCl or salinity stress also led to the increase in the DPPH scavenging activity as well as the ferrocyan scavenging activity. So from these data, we could conclude that basically stress, that is both salinity, nutrient stress in the form of salinity as well as the nitrate stress, can lead to increase in the the bioactive compounds of the algae, which can be effectively used for the feed formulation. Now, for the preparation of the feed from the process, so the algae that the 7th day algae consisting of exposed to 750 ppm of nitrate salinity was basically selected as the potential strain because their maximum amount of carotenoid was obtained. And as I have already told you, that basically skin pigmentation is dependent upon about the amount of carotenoid that is present in the feed. So that particular algal strains were used for, or processed algal strains were used for further formulation or preparation of the feed. Now, this is the pictorial representation where I'm showing the preparation of the feed and to form the total algal feed, and this was basically mixed with the controlled feed to form 25% value added feed, 50% value added feed, and 75% value added feed. After the formulation of after the mixing of all these feed, basically the nutrient parameter analysis of the feed were done, and it revealed that the CF is the short form for commercial feed, and it revealed that 75% value added feed had maximum amount of protein, carbohydrate, crude, lipid, carotenoid, and total phenol content, total flavonoid content, as compared to the commercial feed, where and in this 75% value added feed, we had 75% total algal feed replacing or mixed with 25% controlled biomass. Now, this is the PCA plot showing that maximum amount of the nutrients to be present in case of the algae that we or algae based feed that we are using. Now, after the formulation of the feed, basically they were applied to the different the experimental setup, and for which contained the goldfish as our experimental species, and the experimentation tenure was for 30 days. And after at an interval of 15 days, basically the morphometric data were like extracted, like that is the length, breadth, the width, and of the fishes were compared. They were some fishes were sacrificed, and their protein, carbohydrate, and other nutritive analyses were also done. So in this particular from this particular data, we could find that 50% VAF fed fishes had maximum amount of growth and maximum amount of body weight increase, length increase, and width increased as compared to the controlled setup. Now, the total protein content further also showed that 50% VAF fed fishes had maximum amount of protein, carbohydrate, as well as carotenoid content. Now, basically to estimate or to see what were the different components of the skin pigments that were being stored within the goldfish, the fish flesh or the carcass as well as the skin were extracted from the goldfish, and they were macerated with acetone, and then HPTLC study or high performance thin layer chromatographic study were conducted, and from this data we can see that these are the two standards that were used. One is the astaxanthin and the other one is the beta carotene, and then they were applied in different concentrations, as we can all see. Now from the data itself we can find that basically 30 days 50% VAF fed fishes had maximum amount of the astaxanthin and beta carotene content, and therefore basically therefore this is the peak which is showing the astaxanthin and beta carotene content of the 30 days VAF 50% VAF fed fishes. Now this can come to our mind that basically what happens, the fishes they when they feed on or when they feed on the carotenoid supplied through the feed, basically they convert the beta carotenoid and store them, or the carotenoid in any form of the carotenoids, and store them in the form of the astaxanthin, and this astaxanthin acts as a fortifying system for them, and helps them to strive through various stressful conditions or environmental atrocities, so and help them to stay alive. Now, the total antioxidant capacity study was also done for the experimental and controlled fishes, and it was found that the antioxidant capacity gradually increased with the incorporation of algae into the diet, with the maximum being achieved on 50% supplementation, and the lipid peroxidation, catalase activity, and superoxide dismutase activity were found to be comparatively lesser in case of fishes fed with 50% algae supplementation, and as you can see from the graph itself, there is a considerable decrease in the trend of lipid peroxidation rate, catalase activity, and superoxide dismutase activity in the fish being fed with different variations of algal feed. So therefore from this particular data we can suggest that basically the feed is good for the fishes, and it will not affect the fish health in any way. Therefore, if I would like to conclude, the nutrient stresses generally lead to the development of the reactive oxygen species, and to combat these reactive oxygen species, there is upregulation of different nutrient properties or different bioactive compounds within the cells of the algae, and if we can biotechnologically use them, this will be beneficial for us. Now, since in our cases, since algae exposed to 750 ppm of nitrate on the 7th day had maximum amount of carotenoid content with good amount of polyphenolic content, so this was basically used or selected to formulate the feed, and the value added feed were basically found to be nutritionally rich with high protein, carbohydrate, carotenoid, phenol, and flavonoid content, and the experimental feed where 50% supplementation of controlled feed with the algae based feed are being done, has been found to be effective for Coalesce oretus. Now a question may come to your mind that if I am saying that algae is good for the algae are good for the health of the fish, then why am I not saying that total algal feed, or why my results did not depict that total algal feed to be best for the usage? The reason is that basically like we have developed a taste or taste bud for any feed, or our health also depends upon the acceptability of the feed. Similarly, fish also has they have a percentage of acceptability, and we have found that maximum of 50% value added feed could be effectively accepted by the Coalesce oretus or goldfish, and therefore this since this percentage was maximally utilized by goldfish in our experimentation, therefore we found good results of the particular experiment experimental feed, and astaxanthin level were also found to be maximum in the experimental fish, not only imparting them with bright coloration but also increasing their antioxidant levels, thereby also reducing their mortality rate, which was found to be up to 0%. So thank you.
Thank you very much, Dr. Priyanka. Any queries?
Okay, okay, I think there is no query, so we can move on to the next participant.
Yeah, yes.
Thank you,
Sure.
Shah. Thank you, everybody, for giving me a patient hearing. Thank you.
Thank you. So next presentation by Dr. Boni Sunfan from National Taiwan Ocean University, Taiwan. So presentation title is A Plant Extract of Ithiogan Enhances Welfare and Stress Tolerance of Food Fish and Ornamental Fish During Live Fish Transport, a review.
Hello.
Hello.
Yes. Let me get my PowerPoint on.
Yes, yes. Okay, you can share the screen now.
喂，现在要
You
开
can
始。
share.
好，谢谢。Sorry, just wait for a few minutes. I get it on.
Okay.
Well, thank you for this opportunity that this is my first trial on online international conference. And I'm really happy to share with you what we have been doing. We have been doing using this plant extract. 喂，我没有看到哎。好，已经在等我了。Sorry, there's some problem with the connection. Can you hear me? Hello?
Yes, yes, we can hear you. We are just waiting for your PowerPoint slides.
Yes. Well, we have been working on this plant extract for many years. So what I'm going to share with you is the summary of
Okay.
Okay.
I'm sorry, I have to. 喂，我已经弄了共享。你说什么东西？好，我不动。好好 ，OK。嗯，有没有？ So can you see my PowerPoint?
Yes, yes.
Okay.
It's visible. You can start.
Okay, yes, sorry about the delay. So this is a plant, Glycine tomentella, and in Chinese it's called 一条根, meaning a root. The reason we want to pursue this is that 看见了，喂，看见了。对对对，已经在说了，已经在说。Because in our previous study, we found this extract has many bioactivities. One important aspect is that it seems to be having the anti-stress activity. And then in Taiwan, we had cold front. The cold front caused the mass mortality of many different kinds of fish. For example, this one is a millfish. This is also millfish. And this is a cobia. And all this caused millions and millions of loss. So we really think that we should find something to add to feed to boost up the cold stress. And so we were thinking if there's any way to improve the cold adaptation of fish. And this is the extract, the root, the dry root of this plant. It belongs to the soybean family. And this is the growth of the plant, and then grow into a blossoming. And then this is the whole field. And then we have harvest the root like this. And then the composition of this extract, we use ethanol to extract it. And then it contains the sugar, 55.3%, and isoflavone, 33.1%, and phenolic acids. And then so we identified and make a chemical fingerprint of the, we abbreviated as a GTE, glycine tomentella extract. And then this is the total phenolic compounds. And then isoflavones and the total flavones. And then we make this as the fingerprint of the GTE. And then we use the absorption of at 510 nanometer as the index for the concentration of GTE. And these are the key compounds. The one compound is diazine, and this is the NMR spectrum. We published this in 2005. And then this is another compound, viticin. And then since this is a novel extract, so we have to determine whether it has cytotoxicity. And then we were able to prove that it does not have a gene cytotoxicity. So we have the 4 levels of GTE extract, and then as long as we have it under 250 microgram per milliliter, is okay. And then we also determine there's no cytotoxicity as long as the concentration is 25 microgram per milliliter. So you see the cells were normal, while above 25, and then we see the cells, the TO cells were abnormal. Since we can determine the level of non-toxic, then we decide to determine the functional properties of it. And then the first thing we want to determine is whether it really has anti-co-stress activity. And we fed this to tilapia. And then this is the temperature profile. And we have the temperature dropped from 25, which is the optimum temperature for tilapia. And then drop it to all the way to 8 degrees. And then we see the survival without the GTE extract. You see the survival reduced to about 60%, while we have the GTE, then it survived 100%. So we were able to show that they do. The GTE does have the ability to enhance the anti-cold stress, or in other words, it has a better cold adaptation. And this is the reason why it, well, partially the reason why it can provide this cold adaptation capacity. For one thing is we found that the plasma antioxidant status was improved. For example, we have the blue line is the antioxidant Trolox as a positive control. And then we have 4 levels of GTE. And we do it on in vitro and also ex vivo studied. We were able to see with the GTE in the system, the LDL system with pro-oxidant added to it. And then you see this is the lag phase of the oxidation. And when the yellow one is the control without any GTE, and then it has a very short lag phase. As the GTE increased in concentration, you see the green line is the 10 microgram per milliliter. You see the lag phase is about 200 minutes. And then we increase the concentration to 15 as is shown in the on this one. And you see the lag phase is longer. So we can tell that the lag phase has been prolonged by addition of GTE. And this is the correlation between the concentration of the GTE and also the length of lag phase. And this is for the human LTL. And then this is for tilapia LDL. They all exhibit linear correlation with the concentration and the lag time. And then GTE was also able to increase the total antioxidant status and alpha tocopherol retention in plasma LDL. So you see this is the lag time for control was 52 minutes. For EDTA, GTE is 80 minutes. And then maximum oxidation rate for control was 0.42, while GTE was 0.31. And the total antioxidant status, and then you see for control is 0.24 millimole, and for GTE is 0.43 millimolar, while the alpha tocopherol inside of LDL for control is 8.8, while EDTA retained more as 13. This shows that the GTE kind of protected the alpha tocopherol from being oxidized. So this also helped the plasma to have a higher antioxidant activity or capacity. And then this is very interesting that with the intake of GTE in the feed, and then the fish fed with the GTE for 8 weeks, and you see the total cholesterol was lowered when the feed was like 0.8% body weight per day, and then the total cholesterol was 254 versus 534. And if we increase the feed to 1.6% of body mass per day, and then GT still reduce the total cholesterol to half, almost like half of the control. LDL cholesterol also reduced by like a half, or even more than half of the control. So this shows that feeding GT for only 8 weeks, and you see the effect on plasma LDL and the total cholesterol of the fish. And then if we prolong the feeding time to 12 months, and then followed by control diet for 2 months, and you see the cholesterol was still maintained at a much lower level than the control, as 254 versus 403. And this is another interesting findings that we have not published previous PowerPoint were published. And this we found by feeding GTE to tilapia, and then have the fish exposed to high ammonium chloride stress. And then you see the control has more hemoglobin dimer formation than the GTE fed fish. In other words, the GTE helped to reduce or prevent the dimer formation of hemoglobin. And also, in addition, these are the red cells or erythrocyte, and they they can aggregate, but the control showed more aggregation than the GTE fed. So the next part is that we also tried the GTE spiked in water, packing water for ornamental fish during the live fish transport. All these fish we studied. And this we found that GTE reduced the abnormal behavior of koi during simulated live fish transport. And this is, you can see the koi pre-transport. And this is control, and this commercially use clove oil to sedate the fish, and then we use GTE, and then after the simulated transport, you see the control was in worse shape, and even the clove oil was not keeping the fish as well as the GTE. And although they were all 100% survived, but the behavior was different. When the fish was under stress, it showed the fish roll over. And even with clove oil, it also have a low rollover rate of 40%, while GTE did not get any fish rollover. And we also summarize what the water quality of the packing water. And we have the blank, that means just water in the packing. And then control is with the water, but we also have the simulated transport. We use vibration and use artificial, use a shaker to give the vibration to the fish packed in water. And then this is simulated transport with clove oil added to the water and the GTE added to the water. And then the four showed the blank was just out from the fish tank and then controlled. So the temperature were all the same, while the dissolved oxygen was different. With the GTE, all the control, clove oil, and GTE were all under the same simulated transport condition. And then it shows after a simulated transport, and you see the dissolved oxygen with the GTE was higher than the clove oil and higher than the control. And then the ammonia, and you see with the GTE, the ammonia in the water was lower than the clove oil, and about the same as control. And then the conductivity was lowered. And this is more exciting, that suspended solids in GTE was much lower than the clove oil or control. And then although they were all 100% survival. And this set of data shows that GTE were able to maintain better water quality in the packing water. And also the fish, and we assume the fish, if the fish got excited, and then the plasma cortisol will increase. And you see the control has much higher cortisol level, while the clove oils and the control, and then this is with GTE added, and this is with the GTE added and also with shaking. So the green one is with the GTE added, standing still, and then the blue one is with the GTE added under shaking or simulated transport. And you see with the GTE added, they showed no difference whether standing still or shaking for 2 hours, and for 4 hours also the same, and for 6 hours also. We published this early this year. So in other words, we can tell that GTE reduced plasma cortisol level of coil during the 6-hour simulated transport. And other ornamental fish, for example, guppy or ice blue or blue ali or blood carrot or koi, with a longer simulated transport and with the GTE, they all improve the survival. And especially it's very important for koi, because koi is very expensive. And then our study showed it was able to maintain 100% survival for koi. And then we also tried it on the grouper fry, and also with the GTE improves the survival from 86% to 100%. And this is very interesting, because a previous speaker talked about coloring the ornamental fish. And this was one instance. The parrotfish originally was kind of pale in color, and then the fish, I mean the fish merchant try to color the fish with a different color to make it for all this different kind of color fish. And especially with the green one, the survival rate was not expected. However, when the injection of the pigments with the GTE, it kind of reduced the stress and improved the survival. So, this is the GTE extract, the prototype of a product, and from this root, and then use on coil. And so I think I want to summarize our findings at this point. The GTE developed from root extract is a natural non-cytotoxic anti-stress agent. And the GTE also regulated the physiological responses, including enhanced cold adaptation, increased the total antioxidant status, and reduced the total plasma total cholesterol and LDL, and improved the tocopherol retention in LDL, inhibited hemoglobin dimer formation and erythrocyte aggregation. So this way to prevent the blood clotting at a low temperature. So improve the survival. GTE was more effective than the commercial static such as clove oil used for live fish transport. And GTE regulated the plasma cortisol by lowering its level during live fish transport by reducing its stress level. GTE maintained the water quality by increasing dissolved oxygen, reducing total ammonia nitrogen, resulting 100% survival at increased stocking density during simulated live fish transport of grouper and ornamental fishes. So thank you very much for your attention and also your patience for waiting for me to get connected. Thank you.
Thank you very much, Dr. Boni. So any queries or any remarks? Okay, so next we'll go with the poster presentations. Poster presentation by Dr. George A. Papadomichalikis, Agriculture University of Athens, Greece. And the presentation title is Meat Selenium Concentration and Oxidative Stability in Broiler Chickens Fed Diets with Selenium Nanoparticles Loaded Cytosine Microspheres.
Thank you very much. I hope you can hear me loud and clear, right?
Yes.
Okay. So most of you now will probably wonder what terrestrial animals have to do with aquatic species. I'm going to show you the results of an investigation that we did regarding selenium nanoparticles, which can find great applications as well in aquatic organisms. So, as we all know, selenium is an integral part of at least 25 selenoproteins, which exert multiple biological activities regarding animal growth, performance, fertility, and disease prevention. Some of these selenoproteins are actively involved in antioxidant defense and the redox regulation of the animals by controlling the levels of free radicals that are produced during normal metabolic activity. So because of this importance of selenium, selenium has been considered as an essential trace element which has to be added to the diets of the animals. The problem with the commonly used selenium sources or forms is that they have a narrow margin between beneficial and toxic effects. For example, sodium selenide is quite toxic if a mistake is done during a feed formulation, and selenium yeast is not so toxic, but it accumulates and it may cause a chronic toxicity with time. This is the reason why some other forms have attracted attention as alternative dietary selenium sources in animals. And these forms include selenium nanoparticles. Selenium nanoparticles have unique biological activities. They have high bioavailability and very strong antioxidant activity. But there is a problem. Selenium nanoparticles are thermodynamically unstable, and they tend to aggregate and transform into a gray analog that becomes not available, and it loses its biological activity. This is why these days, when selenium nanoparticles are synthesized, we are trying to stabilize them in capping agents or stabilizers, as they call. One of these stabilizers is chitosan, which is a natural polysaccharide. Is under investigation the last years in biomedicine and has shown very promising results. Nevertheless, the potential of this kind of selenium nanoparticles as dietary selenium sources in livestock and in aquatic species has not been extensively investigated. There is a small problem with chitosan. It works perfectly as a stabilizer, but is not susceptible to endogenous digestive enzymes. So the question arises, if we use selenium nanoparticles that are coated in chitosan, is selenium going to be bioavailable? Is it going to exert its biological activity? So we ended up to look at the efficacy of chitosan-coated selenium nanoparticles in an in vivo experiment in broilers. We compared this form of nanoparticles with sodium selenide and selenium-enriched yeast, which are the most commonly used dietary selenium sources nowadays. We investigated the effects on growth performance to see if we could find any overall selenium effects. And we focused mainly on meat selenium concentration as a means to study the dissolution of chitosan and the bioavailability of selenium. And we also studied meat oxidative stability to see if selenium, which is contained in the chitosan-coated nanoparticles, exerts any biological activity. We used 200 roast broiler chickens in a 3-phase feeding experiment. We had 4 groups. The control group, which fed a basal diet. This basal diet contained no additional selenium. And we had 3 experimental groups, T1, T2, and T3. In all these 3 experimental groups, we added 0.4 milligrams selenium per kilogram. The 0.2 milligrams came from sodium selenide in T1 group, and the other 0.2 milligrams from selenium yeast. In group T2, the 0.2 milligrams came from selenium-enriched yeast, and the other 0.2 milligrams from chitosan-coated selenium nanoparticles. And we had a third group, the T3, where selenium came derived only from selenium nanoparticles. Now, the main objective of this experimental design was to stay within the regulations and the guidelines of European Union regarding selenium content, dietary selenium content. These guidelines strongly indicate that selenium, total selenium in the diet should not exceed 0.5 milligrams per kilogram, including the added and the natural occurring selenium. Oh, sorry. Oh, okay. So we have this experiment for 42 days, and our first concern was to see if we were within the guidelines of the European Union. So as you can see in the first line of the table, we analyzed the feed samples from all experimental groups, and as you can see, we achieved the target of the experimental design. We added 0.4 milligrams, and we stayed within the limit of 0.5 milligrams and suggested or recommended by the European Union. The first thing that we checked was the performance of the animals. As you can see in the table, feed intake, weight gain, feed conversion ratio, and carcass traits were not affected by sodium selenite, by selenium-enriched yeast, or by selenium nanoparticles in comparison with the control diet. So that shows that selenium did not have any effect on animal performance in any form, either in organic, or nanoparticle form. This was not a surprising finding, because actually selenium affects performance in very, very specific circumstances. For example, when the basal diet is selenium deficient, or when we have very harsh environmental conditions during rearing, for example, elevated environmental temperatures. So these findings were not to our surprise. Secondly, as you can see in figure 1, we checked meat selenium concentration at the end of the experiment. The dietary supplementation with sodium selenite and selenium yeast, with selenium yeast and selenium nanoparticles, or with nanoparticles alone, did not have, there were no difference between these three experimental groups. But all these three groups were, the meat selenium content was significantly different from that of the control group. That shows that selenium was bioavailable. And it was bioavailable as well from the selenium nanoparticles, which were coated with chitosan. And this finding clearly indicates that chitosan is being dissolved in the gastrointestinal tract of the broilers. Now, there are some mechanisms that may be involved in the dissolution of chitosan. Some researchers propose that these stomach acids, for example, that dissolve chitosan, because chitosan is a polysaccharide and is very sensitive to even to diluted acids. Some other researchers have proposed that the dissolution of chitosan takes place because of free radical species that are being produced in the digestive system of the animals during the normal digestion procedures. In any case, it remains to be clarified what exactly is the mechanism that dissolves chitosan and releases selenium nanoparticles, and consequently selenium becomes bioavailable. In the third place, we evaluated the effect of the selenium source on the NDA concentration, on malondihaldehyde concentration in meat. We didn't run a single analysis of NDA because exactly we wanted to see the oxidative stability, so we induced actually the meat oxidation using a mixture of ferrum sulfate and hydrogen peroxide. And then we measured at the specific time intervals, as you can see in the figure, the MDA concentrations. Now, from this figure, we can see that the MDA concentrations in T1, T2, and T3 fed broilers were significantly lower than those found in the control after 300 minutes of oxidation. That indicates that selenium, either from sodium selenite or from selenium yeast, but most importantly from the selenium nanoparticles, had a very strong antioxidant potential. So, what we concluded from this work, first of all, selenium content can be readily increased in the meat by using selenium nanoparticles and in a manner that is very similar to the commonly used selenium sources. That means that it is bioavailable. Selenium contained in the selenium nanoparticles, it is bioavailable in a very similar manner to the commonly used sources. We also found that selenium from selenium nanoparticles also improved breast oxidative stability in a manner which was again comparable to the commonly used selenium sources. Our results indicate that selenium nanoparticles coated in chitosan can be a potential source of bioavailable selenium with an important protective role against meat oxidation and merits further investigation not only in broiler feeding, as you can see in the presentation, but also in aquatic organisms. Why they can be such a good source of bioavailable selenium. The main advantage of selenium nanoparticles is the low toxicity. Selenium nanoparticles are 18 times less toxic than sodium selenite and 7 to 8 times less toxic than selenium enriched yeast or other organic forms of selenium. So it is a very good strategy to use selenium in a form that is much less toxic and may allow for using maybe different dietary levels in the future, which can be very, very beneficial to the animals. And now this kind of studies has already been conducted in aquatic organisms as well. I found a couple of publications regarding the use of selenium nanoparticles coated in chitosan in tilapia, with very good results on the performance of the fish and on the antioxidant defense of the organism of the fish. So this is the connection actually between the broilers and the fish. We believe that all this science around nanotechnology and the synthesis of selenium nanoparticles coated in various stabilizers merits further investigation because it's going to be a very good strategy. And why? Because we can use this strategy to convert, for example, sodium selenite into something that is much safer as a dietary selenium source in animals. I would like to thank you for your attention, and I'm open to any questions you may have. I don't know if there are any questions.
Thank you very much, Dr. George. So any queries?
Any questions?
Okay, I hope there are no queries.
It's okay.
Okay, if any queries, please mention in the chat box so that we'll continue the discussion.
So the stage belongs to Mrs. Katia Vieira now.
Yes.
Thank you very much.
Yeah, thank you. So next post presentation by Dr. Katia Vieira from University of Aveiro, Portugal. The presentation title is Antimicrobial Photodynamic Therapy as an Innovative Approach to Inactivate Escherichia coli on Sea Bass Fillets. Can you zoom it? Hello, Katja, we cannot hear you clearly. Your voice is not audible. Hello, Katya. Disconnect your headset and plug in it. Actually, there is a disturbance in your audio. That's the problem.
Actually, I guess there is a problem with your headset because your voice is breaking in between. I could hear some noises from you. Maybe you can completely remove your headset and just talk. You are lightly audible, like very mild voice of yours. Yes. Yes, you could try the recorded presentation. maybe it's actually not audible to us. So maybe you can send us an email with the presentation and we can put it on like from our side. So in the meantime, maybe we can continue with the next presentation by the time we'll get the presentation from Dr. Katya. So for the next presentation, we have Dr. Konstantina Luchava from ELGO Demeter, Greece. Yes, your screen is visible to us.
Can you hear me?
Yes, we can hear you.
Yes. I have a bad internet connection, so I would prefer closing
Yes.
the video. So
yes, that's great. Yeah.
that is why I have here my picture with my CV. So I'm Dr. Konstantina Pitchava. I'm a researcher at the Veterinary Research Institute in Greece, working with diseases of aquatic organisms. My activities are the surveillance and prevention of the health of farmed marine and freshwater fish species, as well as shellfish and crustaceans. And we are very interested in the development of vaccines. That is why I will present to you now a new project that we have, which is Super Trout. So, if you can see my screen well, our new project involves the improving of sustainability and performance of aquaculture farming system with the goal to breed for lactobacillus resistance rainbow trout and also to produce a recombinant vaccine for this fish pathogen. Aquaculture, as a background, we must say that aquaculture represents the winning strategy to face the depletion of fish resources due to the constant growth of world population. Small-scale farming systems are common in the Mediterranean area, and trout farming is suitable for this purpose by efficiently exploiting surface and underground water resources. Italy, Turkey, Spain, and Greece are at the top of the list of the main producers of rainbow trout, the species Oncorhynchus micis. The increase in the demand for aquaculture products brings with it the need to make production systems more efficient and sustainable. This entails a management and technological improvement, including the development of vaccines, the reproductive aspects, and the genetic selection of characters related both to productive traits and to disease resistance. For this reason, the overall objective of Super Trout is to improve sustainability and profitability of small-scale farming systems facing lactococcosis in rainbow trout by applying innovative strategies based on exploitation of natural genetic resistance of trout through marker-assisted selection, and then the development of recombinant vaccine to be administered by immersion, which is something innovative, since there are commercial vaccines by now that are actually used with injection. But small-scale farming systems, for these systems, sometimes the injection of fish one by one is not a very economically profitable manner. So by this way, by immersion, we have an innovative goal, something which is would be very suitable and easy to use for small-scale farming systems. And of course, with the marker-assisted selection system, we will improve the reproductive performances, exploiting the trout genetic features. SuperTrout is a 3-year project funded by the PRIMA, which is a partnership for research and innovation in the Mediterranean area. 4 countries, as I already mentioned, Italy, Spain, Greece, and Turkey, and 6 partners of these countries are the consortium of this project. And they are all working with farmers from all the countries to develop genetic resistant broodstock. Additionally, the strains from all the countries will be analyzed by molecular methods in order to develop a recombinant protein vaccine for lactococcosis that will be administered to the animals by immersion in order to reduce the cost for the farm systems. As a conclusion, using this approach, costs related to the disease control will be reduced, the profitability will be increased, while sustainability will be enhanced, reducing environmental contamination due to antibiotic treatment and reducing antibiotic-resistant strains. So that was the presentation of our project. I will put again my photo here to see my email, and anyone who is interested in what we are doing, and we can communicate with him and see what is going on in their countries and see how we can all work together in this project. As I already mentioned, there are commercial vaccines for lactococcosis, but because of because of the differences in the strains in our countries, in the 4 countries I already mentioned, we can see that these commercial vaccines are now starting to be inefficient. That is why we have built this project, and we are very optimistic about the results. Thank you very much, and we will enjoy again the webinar tomorrow.
Thank you very much, Dr. Constantina. So any queries? So there is a question for you, Dr. Constantina, from D. Leo. Why existing vaccines are losing efficacy?
You asked me why the vaccines are losing efficacy?
Yes.
Yes. We are now exploring the strains. The commercial vaccines have 2 specific strains. One strain is from Spain and another is the Italian strain. But now that we have already started the project, we are analyzing the strains that we isolate from different countries, and we can see that different clusters are developed, and there are a lot of differences in the genetic profile of these strains. So while the commercial vaccine, that is empirically what I'm telling you, while the commercial vaccine from Spain is working very well in Greece, it is not working, it is losing its efficacy in Turkey. In Turkey, it's not working very well. And now that we have completed our first genomic research from the strains, we saw that genetically, the isolates from Spain and the isolates from Turkey are away. So that means that actually this vaccine is not a good candidate for the commercial vaccine is not a good candidate for Turkey. And now, within this project, we will find all the proteins, the proteins that are common in all the strains that we are collecting, in order to make recombinant protein vaccines that will be efficient for all the strains. If I have covered you?
Yes. Yes, thank you very much.
Thank you. Thank you also.
Yeah. So I would like to know whether Dr. Ketia is ready to present now. I think she's not ready to present it now. So we'll go with oral presentations. Oral presentation by Dr. Anupam Ghosh from Asian Marine Conservation Association, India. You are in mute. Yes, your screen is visible, but you can start your presentation now.
Sorry, the presentation is not yet in presentation mode.
Oh, yes, your screen is visible. You can start now.
It is in
And
the presenter
audio is also
mode,
clear.
not presentation mode.
Okay, okay.
And we cannot hear him.
Yeah,
He's
you
not,
can start.
we cannot hear Dr. Ghosh.
Dr. Anupam, can you speak? We cannot hear your voice. Can you please check your audio settings again? We can see your slides, but not the voice.
Hello, do you hear me?
Yes, we can hear you now.
Oh,
Yes, fantastic.
Can you share your screen?
yeah, I'm trying to do these things. Screen. Can you see my slide over there in the screen? Hello?
Yes, we can see your slides. Yes, we can see your slides.
Okay,
Dr.
okay.
Dr. Ghosh, you should go in slideshow menu and go in presentation mode. Otherwise, we're seeing the presenter mode, which is small.
Oh.
Okay?
Yeah, I got your point. So, just a minute. Kindly bear with me.
Yep.
We can hear you.
Can you go in slideshow?
Yeah.
Yeah, you can see it on the top left after animations. You
Top
can see slideshow option. Home, insert, design, animations, and slideshow. In the top.
Okay.
To the left. To the left. You have home, insert, design, animation, slideshow.
And then slideshow.
Just below, a little bit more to the left with your mouse. Dr.
Click
Ghosh.
on the slideshow.
Exactly. Go down a little bit more to the left. Just a little bit more. Exactly. Go down. Exactly there. Go down and click on slideshow. Good. Perfect. Click there.
Thank you very much. Thank you.
Just give it time to change. It's not changing. Okay. Now from the beginning, click there in the ribbon from the beginning. in the ribbon up, go up, go up. Okay, down now, a little bit more down. You're looking to the left now. Go to the left, go to the left. More, the very first icon. Down, go down, down, down a little bit. There, click there from the beginning. Okay. Perfect. Now you can go, Dr. Gash.
Okay. Thank you. So this paper is an outcome of a big project. That project was started in the year 1988. So now this paper is on the basis of some outcome result and entitled Impact of Coastal Pollution and Acidification on Fishery Production at East Coast of India. Means the work was done on the northwestern part of Bay of Bengal, covering the coast of east coast of India, entailing two provincial state of India. One is Odisha and another is Andhra Pradesh. Both are coastal states, having although the landlocked portion of the states are there, but most of the people residing on the coast, their profession is they are the fishermen. So actually, when as a part of our study, we found that the fishermen, they are shifting their profession of fishing on the high sea, fishing on the coastal water, likewise. So we started that our physicochemical analysis as well as petroleum oil detection in the coastal water as well as sediment also at the same time, we started the reason for less production of capture fishery from the high sea as well as in the coastal water. And surprisingly, we found that everybody says that there is a huge, according to them, significant reduction in the fish catch from the marine and coastal system. That means what? That means the marine and coastal ecosystem services are being interrupted. So we started to find out the reason behind it. Already we are had so many plethora of data. We started once again to rethink the matter, and now this paper is an outcome that the application of all these physicochemical parameters, say we are more interested and more emphasizing the ocean acidification. We have found that there is a branch line of this application of science. Application of science means applied science, finding out something in science, maybe application in the society, application for the society. And that's why this paper based on three methodology. We are not going to discuss all this detail, how it was extracted, oils, petroleum, hydrocarbon extracted. All these are established method, and for long I started my work over there at Harvard University as well as in Bermuda long back in the year 1982. Now what I would like to emphasize, that all these scientific data gathered in the journal, what is the application of that all this data to the lifestyle of all these fishermen, those who are losing day after day, those who are losing their earning livelihood. And most of the people I will just after some time I will show a video clipping, two video clipping from two different states, Odisha and Visakhapatnam, that means Andhra Pradesh. Everybody, I'm sure that you will enjoy that. What is the reason behind it? Nobody knows. But in the government report, I will show also the government report, up-to-date report, that the fish catch in that report is, while increasing, but fish in our presence, our scientists, AMCA scientists, in presence of AMCA, so many scientists over there at Vijayanathanam as well as in so many location of coastal Odisha, that the fish catch was highly reduced. So one thing is this, that because of petroleum oil pollution as well as because of reducing the pH, ocean acidification, it's not that acidification, that hydrochloric acid or sulfuric acid or something like that. Acidification means the even 0.2 decimal reduction in the pH in the natural marine ecosystem, particularly in water as well as in sediment. So we have shifted our site to three basic parameters. One is physicochemical parameters, detection of whether it has been shifted or significantly shifted or even not shifted. Even if not shifted, what is the impact? If it is shifted, what is the impact? Or if it is as it is remaining as it was to 10 years, 1 decade or 2 decades back. So our methodology concentrate in number one, planning of experimentation. Planning of the experiment on previous result on acidification that I have already told you. Second is chemical and physicochemical analysis of sediment and water of the coastal site, coastal zone of Bay of Bengal in the study area. And the third one is a visual observation on the fish market for survey, including the interviewing of fishermen and fisherwomen. There is one of the most important point is this: in the coastal in the eastern side of India, that is the western side of the Bay of Bengal, particularly northwestern side of the Bay of Bengal, down to the southwestern coast of Bay of Bengal. Most of the people, those who are residing at the nearby coastal zone, are fishermen, either fishermen or women, rather fisher people, and they are the agricultural people. Now I would like to show this, that what is our study area. This is on the left side. This is India's map. Here there are clearly two states are there. One is Andhra Pradesh. This is coastal Andhra Pradesh, this portion, and this is coastal Odisha. Here it is. So in coastal Andhra Pradesh, we started our program from Bhimunipatnam, that is on the north side of the west coast, east coast of India, and starting in the Odisha. The exact name of the location was Chandrabhaga, Puri, Balasore, and the geographical coordinates are here in this picture. If anyone is becoming interested, then I can show jolly well if it is written to me in my email. The second, now it is parameter of study. Parameter of study, I have already told that physicochemical study, that is routine work, mean values of pH, salinity, temperature, etc., and other physicochemical parameter like air temperature, water temperature, wind pattern, everything. And second is determination of total petroleum hydrocarbons. Total petroleum hydrocarbon, as because so many petroleum oil fractions are there, both soluble oil fraction as well as insoluble oil fractions are there, and also the burning oil, half burnt oil, because there are three major ports are there located in these two states. One is Vijayanathanam port, another is Paradip in Odisha, and there is another port in Odisha that is newly being developed. So it is expected that ships will be coming and going, particularly with these cargo ships, and will release their ballast water onto the surface sea water. Naturally, all this soluble fraction of this oil, particularly all these oils are mainly carbon 21 to carbon 27. All these carbon chain are very dangerous. So whenever toxic at the same time, whenever it is coming in the in contact with the coastal water, even if it is in the high sea with the high tidal water, it comes to the coastal side, and coastal side, particularly in narrating zone where sunlight is penetrating, all this green plant, green algae, as well as on green algae and green aquatic plant, all these fishes, those who are maintaining their livelihood as well as spawning and all these things, total life cycle. So these are dead. I have found it out personally, and all my scientists from AMCA at different times, we have found that so many fishes are dead whenever coming to tidal water, high tide. So anyway, we have tried to know whether this Odisha coastal water as well as Visakhapatnam, means Andhra coastal water, is containing any petroleum oil spill or not. So we have started sample collection. All these are routine work, and it is established, and particularly we have followed with slight modifications the UNESCO's procedure in the year 1995. That is well established, and time to time, because of location is changed, because of experimental design is changing, so it is modified. So it doesn't matter. Matter is that we have in determining the total petroleum hydrocarbon, because our motivation is that we have seen for last now it is 2021, since 1998 the third decimal pH is reducing. Reducing means actually the typical pH of this part of Bay of Bengal, it was in 1998, it was in 8.02, something like that. Now it is somewhere else. My student, my other researcher, they are also finding on the regular basis. Only difference is this, that in Odisha it is slightly less, in Visakhapatnam it is more profound. That is it is almost, it is considerable to think over the matter whether the ecosystem security has been infringed or not. And if it is so, then it is obvious that on the basis of that coastal ecosystem, all this fish and fishery, means squids and other things that are exportable items from India, that are all reduced in production, means fish catch by it is the opinion of the fisherman community. It is not individual fisherman that one may have error in his statement. It is the fisherman community as well as fisherman cooperative. I am just going to show this thing. Anyway, this is how we in the field we are by this moment I must clear it that we are doing all these things, pH, everything, all these things with digital gadget. Because earlier what we have done is that taking a sample from field to laboratory, most of the time we are doing analysis in the chemistry lab of Andhra University at Visakhapatnam. But even if, particularly whenever we are collecting this sample, water sample or sediment sample from long far away from Andhra University, 37 kilometers away from the main point of Visakhapatnam, so it may something which is having a significant differentiation with the value that taken or determined on site. So this is the research scholar, and Vinita, who is also participating in this lecture, is doing measuring pH. This is me, and this is another one that I personally invite all these fisher community people to what is their problem, what is the reason behind their reduced rate of fish catching. And because of this reduced rate of fish catching, you can see jolly well here, after whole night fish catching effort, in the morning you can jolly well presume that only a few fish caught by the fishermen, and they are selling to the local fishermen. Those are the vendor and sitting in the market for selling their community to earn livelihood. Now, so this is our routine research work. VSKP means Visakhapatnam. PC is all this data is more than 100 data. 100 data means in 3 spots in Odisha coast. This is Odisha coast and this is Andhra coast. PC means Puri, Chandrabhaga and Balasore. All these things, it can be jolly well found out in the map. So in 2009, I started this paper, or starting from 2009, although we are having all this data from the previous years also, but these are most significant as because this is something as if somebody has just placed this data. But actually seawater, now it is seawater pH. In 2009, seawater pH was 7.546, and this is direct reading in the electronic gadget. In 2009, whereas in the coastal state, in the coastal water of Odisha, it is 7.791. That means typically it is not satisfying the exact pH of Bay of Bengal, particularly northern Bay of Bengal. It is generally, typically northern Bay of Bengal pH coastal water is, other than Bangladesh, is 8.1. So it is reducing much earlier. We may not have that data, but we have found from 2009 to 2021, even surprisingly, I have, and with all my local researcher over there at Visakhapatnam, we detected the data after lockdown. Surprisingly, just a minute, that 2020, then lockdown declared was 2019 in India, 26 March 2020, and 2021 Visakhapatnam and Odisha, Andhra and Odisha, it was a trend. It was a trend. Just a minute. No, it is the screen. এটা বন্ধ কি করে করা যাবে? এটা বন্ধ থাকে। In PC means in coastal state, coastal Odisha, coastal water of Odisha and Visakhapatnam. No, এমনি বলে যাচ্ছি। So seawater pH, this pH once again after 2020, after 1.5 years, more than 1.5 years lockdown, there was total closed of all industry and everything. There is a tendency to revive once again the 7.5 to 7.889. That means what? Here it is 7. And even 2021, because it is not ready effect we are finding. Everything, whatever it is in the natural ecosystem goes on, we are finding, say, cause and effect. If you presume this thing cause and effect, effect is in the effect is profound or appear in the late stage. Here it is in 2017, whereas Visakhapatnam water pH is 7.012 and Odisha is 7. Odisha as compared to that of in whenever we consider that seawater pH in Odisha and Andhra state, we are all the time finding it this, that the acidity rate of acidification or the total value what we have found or detected or determined, whatever it is much more, acidification is much more profound in Visakhapatnam to Bhiwanipatnam as compared to that of Odisha coast. This is clear, and this is rather surprisingly having a tendency to recover. If we find here it is 2020, there is a reduction 7.546 to 7.106 to 7. Here it is once again increased 7.10 to 7. 2020 Visakhapatnam water shows 6.9. That means rate of acidification, means lowering of pH much more profound in 2020. That means the effect, whether it is because of carbon dioxide coming onto the sea surface water from the nearby coastal zone, nearby all industry located in the coastal zone of Visakhapatnam as well as Vijayanagram, and all this carbon dioxide being released, sometimes more often It is without any pollution control norms. I will show you just after some time norms. So the it is causing the lowering of pH, means acidification. And whenever we are finding that, it is luckily that we are having a COVID situation, and we have faced the lockdown situation, so that we can find it out that the carbon dioxide, the major culprit for acidification, which has been clearly proved, or it is clear evidence that from 2020 to 2021, this rapid means we are doing this thing between December to January. Every year it is being done that. So just by 1 year, it is very surprising, very surprising. It is not 1 or 2 data we are doing, and all these things are AC. We have not given in AC, means plus minus standard error, determining that all this statistically determined. And in 2021, in Odisha is little rate of acidification is slightly less because of the same effect of not releasing any carbon dioxide or any activity of energy consumption in the air, means atmosphere nearby. So all these things are here. So now there is another most important point is this, I have already told you, that 2009 BSKP total petroleum hydrocarbon is this. That means over there during that time, no shipping in the port activity or shipping activity in the high sea or the coastal water was there. That's why there was no release. If it is so, although not it is established by any chemical experimentation, but it is clear because this is experiment for the experiment. We are going to start another experiment, but this experiment is experiment for the experiment, but it is not no less important because it is indicating sorry, it is indicating that the role of petroleum oil in the acidification, there is a role. We would have to find it out what is the role, and that is on fundamental chemistry and biological chemistry. But before that, we are actually having that that impression that there is a role or the relation of total petroleum hydrocarbon and the dissolved oxygen. Means in the meanwhile, we are having data, so many data on the coastal algae degeneration because of establishment of Visakhapatnam port and because of oil spill, as well as urban wastes are also there that directly thrown into the sea. Although there are so many litigation case was there, now it is stopped, but already what the harm was done has done. So this is government report. This is up-to-date government report. Here it is. This blue bar is for marine product from 2005 to 2006 to 2017, 2018, except 2011, 12 and 12, 13. This data is reducing. Otherwise, all the time increasing. All the time increasing. It is government data. I do not like to comment over government data, but all the time increasing the fish catch. And the fishermen and fisherwomen, they are leaving their profession because of earning money, because of less fish catch. They are the field worker. Ground reality is this: they are not getting any fish to sell this thing profitably so that they can sustain their livelihood. Now I would like to show you one thing. What is the interview in the Odisha state of fishermen cooperative. This is a big one, but I would like to show the most important. Just a minute.
মাছটা কমার একটা মেন কারণ হচ্ছে এই যে ট্রলারগুলা কন্টিনিউ যে সমুদ্রের ভিতরে কৃত্রিম মাছ মানে ফিশিং করছে, তার জন্য মাছটা প্রচুর পরিমাণে হচ্ছে মাছ মরছে সমুদ্রটা। সেটা ফিশিং এর কোনো টাইম টেবিল থাকে না, সব সময় ফিশিং করে।
Dr. Anupam, are you going to show something to us?
4 মাস টোটাল ফোন করবে, 4 মাস ফোন করলে পুরো টোটাল ফিশিং করবে, তাহলে মাছের বহু আমাদের জীবিকা সময় 4 মাস জীবিকা তাহলে সরকার দিবে।
Hello. Hello.
Do you hear me?
Yes, I can hear you. Are you going to show something?
Yeah.
Yes, we can able to see your
Okay.
Video, I would like to show something that during the interview they are clearly appended that the fish catch is reducing, and reducing because of what they do not know. Only they are interested to have some subsidy from the government. Only subsidy cannot sustain a country or a nation reliant. So that is why we would like to find out, and that is why our research is going on. What is the reason behind it for the less fish catch from the coastal water as well as from in the high sea? And my next one is
Dr. Anupam, you can show your video or at the end, because we have the presentation from Dr. Katya, because we have. Okay. So thank you.
So now I am going to the last part of the discussion part.
Yes, you can show your video in the last. There is no problem. But meanwhile, we'll go with the poster presentation from Katia Vieira, University of Aveiro, Portugal. She is having some audio problem right in the beginning, so yeah, we postponed her presentation that time. So we'll have her presentation now. Dr. Katia, are you
now it is not visible.
ready now?
It was visible, but now it is
No,
closed.
actually this VLC is not.
No,
only we can see the. We can see only the image. Is this one you are going to? Yes, we can see.
So this is the discussion. That means we are not going to conclude anything, but what we would like to say is that because of reducing the pH and because of increasing the oil spill, oil content, total petroleum hydrocarbon, there are so many carbon chain, different carbon, including the burnt oil also. We are not going to qualify or detecting the amount. What we have detected is that oil is present, and because of oil is present and reducing the pH, and if oil is present, then the algal portion are dying. If algal portion are dying, then the carbon dioxide, binding carbon dioxide from the atmosphere it is not workable. If it is not workable, then the carbon dioxide whenever it is coming into the surface seawater, it produces the acid, and that is one of the reason, might have been one of the reason, that the pH at this point decibel level is reducing, and that may be one of the reason for what the fish production. We do not know exactly what for this feed production is drastically reduced for last 10-12 years, and this is something it appears from the report of the government. I have already told that all the years from 2005-6 the marine fishery production has been increased till to date, but unfortunately our research that includes routine analysis of physicochemical properties of seawater, abundance and disappearance of coastal algal growth, petroleum hydrocarbon content in seawater and sediment, and on the whole the fish catch quantity speaks different. That means we are disagree with the government report. Given the scenario, instead of making any comment or concluding anything, now I would like to show the ground reality that I have already shown. The fisher people who speaks candidly. Having watched all this, you the viewers advise me with your good suggestion so that the service of the marine or coastal ecosystem should not be parted or interrupted for the sustenance of the coastal society. That means of what coastal economic growth is a major part. If coastal economic growth sustains, then the coastal society would sustain and everything would be sustained. Thank you very much.
Yeah, thank you very much, Dr. Anupam. So any queries, please go ahead or just text me in the chat box. So meanwhile, I would like to know about the presentation from Dr. Katya. Are you ready now? Can you zoom it?
Hello, I am Katia Vieira, a PhD student in the University of Aveiro from Portugal and University of Vigo from Spain. Today, I am going to present you a new technology we have been developing to inactivate Escherichia E. coli and other pathogenic bacteria on sea bass fillet. As you may know, aquaculture is a continuously growing sector of worldwide importance that provides nearly half of total fish production. However, the proliferation of pathogenic bacteria in aquaculture systems, together with improper handling of fish during processing, can lead to the deterioration of food products and endanger consumers. Moreover, there are few antimicrobial techniques available to control these infections, and their application can even result in adverse effects. Therefore, to address these challenges, innovative antimicrobial approaches must be developed. Recently, antimicrobial photodynamic therapy, a technique that combines a photosensitizer, a light source, and molecular oxygen, is gaining a special attention as an efficient approach to inactivate microorganisms in food matrices. Thus, the aim of this study was to investigate the photodynamic inactivation of bacteria in sea bass fillet. To perform this study, we selected Escherichia E. coli as a gram-negative bacterial model, considering its often introduction during food processing and its danger to human health. To achieve this goal, preliminary assays were firstly performed in buffer to assess the photodynamic efficiency of two photosensitizers, a porphyrin and a dye, in combination with potassium iodide. Afterwards, the photodynamic treatments were also performed in the flesh and skin of sea bass fillet contaminated with E. coli. The results obtained in in vitro experiments show that the porphyrin and the dye at 0.5 micromolar were efficient to photoinactivate E. coli until the detection limit of the method after 30 and 45 minutes of treatment, respectively. Moreover, the application of potassium iodide improved the PDT efficiency of both compounds, allowing to reduce the treatment time to 5 minutes. The treatments performed in sea bass fillet were also efficient. The results summarized in the figures show that both photosensitizers in combination with potassium iodide permitted the reduction of 95 to 99% of E. coli survival. These results are really promising and suggest that a PDT can be an efficient antimicrobial approach to disinfect fish products and to provide safe food to the consumer. I am grateful for your attention.
Thank you, Dr. Katia. So any queries, please mention in the chat box or you can ask directly. Now, yeah, I hope there are no queries. If any queries, please mention in the chat box. So next oral presentation is by Dr. Giulio A. Dilio from Hopkins Marine Station and Woods Institute for the Environment, Stanford University, USA. And the presentation title is The Role of Small-Scale Freshwater Aquaculture in the Biological Control of Snail-Borne Diseases of Public Health and Veterinary Importance.
Okay, you need to make me a presenter.
Yeah, I have made you the presenter. Can you please check now?
Yeah. Can you see my slides?
Yes, that's perfect. It's visible.
Okay, let me see how. Yeah, I don't see myself, but hopefully it's working fine. So you can hear me, right?
Yes, it's very clear.
Okay, let me see if I can get rid. I have too much stuff on. What happens if I do this? No. Okay, let's make me leave. Oh, here. Yeah, interesting. This software. Okay, got it. Okay, perfect. So, good morning and good afternoon to everybody. I'm Giulio De Leo. I am a disease ecologist based here at the Hopkins Marine Station of Stanford University. And today I'm going to talk to you about how small-scale freshwater aquaculture can help in fighting important snail-borne diseases of public health and veterinary importance. Before I start my presentation, I want to acknowledge the amazing network of collaborators, of institutions and partners and founders that made these available. And I cannot name them all. That's the reason I put their name here in the introductory slides. There are at least more than 9 countries and basically 3 continents have been working on this project. And I want also to thank my funders, the Bill and Melinda Gates Foundation, the National Science Foundation of the United States, and the Belmont Forum of Climate, Environment, Health in Action, and the Woods Institute for the Environment. So this would not be possible, and this is truly a joint collaboration among all these people. My presentation today is gonna start from some preliminary consideration of the research question. Then I'm gonna move and show you 5 pieces of evidence of predation control in snail-borne trematode infections. And last, I will conclude by showing what I think is the way ahead. So let me start from the first point, the preliminary consideration and research question. So this is Aquaculture and Fishery Conference. So there is no need probably to remind how important is aquaculture in general. The most rapidly growing food sectors, as Dr. Katia Vieira just said before, for feeding a growing humanity. If you have not seen yet, I strongly recommend you to look at the Blue Food Assessment that the Nature Scientific Journal just published a couple of months ago. It's an amazing venture that encompasses more than 100 scientists for 20 different institutions, assessing basically blue food production from every point of view, from the demand, from the environmental impact, the climatic impact, environmental justice, and for the support to fight poverty and hunger. So I think we all agree, and I reported here the 3 classic sustainable development goals that aquaculture can help basically to achieve. That is to fight poverty through the support of small-scale fishery, fight hunger because blue food in general is so nutritious, and also improve health through this one. The health side is the one I want you to focus for the talk today, to see a different perspective for the nutritional one. And when I say that, I just want to acknowledge nutrition is absolutely important. I just want to bring emphasis and say that that aquaculture might also help to fight important parasitic diseases. I show you here in this diagram the fact that there's a big family of parasitic diseases of poverty. The most important one is probably schistosomiasis, which is my reference model system, is the one I know the best. And there are other diseases that are waterborne or vector-borne. They all share 3 common features. The first one, they all have an important environmental component in their transmission cycle. And this is really relevant from what I said. And the second is that all disease of poverty in general. And the third one, that in general, with some notable exception, they do not provide long-lasting immunity. There are no vaccine, or at least known cost-effective vaccine. And the only things that you can do is to treat people with drugs. They provide only a temporary relief because drugs themselves do not prevent reinfection. And so we can treat people, but then they get reinfected if we do not remove the source of the hazard. Therefore, there is a general consensus, including the WHO, the World Health Organization, that we need to target also the environmental reservoir of the disease. So this is the case of human diseases, but when we go to trematode infestations in aquaculture, is the same problem. In this specific case, we talk again about infection that are transmitted through a complex life cycle that include mollusks, like melanoides, for instance, the cercaria that infect fish. The fish are eaten by birds, and the bird, where the worms develop as an adult and reproduce, the eggs are released back in the water. They infect the snails to complete the life cycles. I will, in this specific case, trematode infestation are actually threatening this growing sector of aquaculture, and because of more favorable environmental conditions like increasing temperature, this infestation are occurring at an increasing rate. So even in this case, it is necessary to control the intermediate host snail. So we basically try to get rid of the snail. And there are several ways of doing that. And one is to use molluscicide. Molluscicide are very effective in control snail in the short term. You spread them and you're most likely going to kill most of the snails. But usually they provide only a temporary relief, because once the molluscicide is removed from water circulation, the snails can grow back into the system. In addition, repeated applications of molluscicide causes negative environmental impact, basically water contamination that affect all the fauna of the water downstream, potentially even kilometers far away. So they're not good from this point of view. Last but not least, they may also lead to selection for resistance, which is a huge problem, because then you need to use more and more molluscicide, to the point that they're not effective anymore, but they cause a huge environmental and ecological impact. So the overarching question of my presentation today is that whether we can use aquaculture species as biological control agents of snail-borne trematode infection. And we're going to do that with reference to two specific systems. One is schistosomiasis, also called the snail fever, is a debilitating disease of poverty that is endemic in sub-Saharan Africa, but also is a pocket of transmission in South America and also in Asia. In the parasite is a parasite, and especially the Schistosoma aviatobium is an obligate parasite that includes humans in the transmission cycles, and infected human release eggs, go in the water, infect the snails, and then the snail shed this cercaria. When people step into the water, get infected, then they can get infected by the parasites. And I will also make a small reference to a work that some colleagues of mine in Israel are doing on trematode infections in tilapia farms. I'm going to talk specifically of these two. And I also want to remember that these are two very interesting systems, but I am expecting in the audience to find other suggestions of system where this could be applied. So let's go forward and just mention that when we talk about biological control agent, we're not saying anything particularly new, at least in agriculture, right? Integrated pest management, it's a concept that is very well rooted in agriculture in at least last century. But the first examples are dating back almost 2000 years ago. The word biological control was first used in 1919. And if you today you look, you Google in biological control and pest, you'll find at least 10 million instances. So there is a lot of work that is done on integrated pest management. We know that it can work, and under specific circumstances, it can spare use of otherwise harming insecticide. There is much less evidence when we move to human diseases. Phage therapy was this idea of using viruses to come back to fight basically antibiotic resistance infection in these days, which is basically living a second renaissance. The first ideas of using viruses actually dates back almost to a century ago, to studies that were mostly conducted in the former Soviet Union. Wolbachia is also Rickettsia-like bacteria has been also considered to fight mosquitoes-borne disease because the bacteria naturally infects a wide range of insects, and so it can be used as biopesticide basically against mosquitoes. And larvae-for fish for preventing malaria transmission have been shown to work, at least in laboratory experiment, but this is mostly it. So let's go now to the trematode infections, of which I know a little bit more, and I'm going to present you 6 pieces of evidence of predation control in snail-borne trematode infection. First piece of evidence is the evidence following an intentional removal of predator. Okay, oops, what happened? Did I lose the screen? Oops, okay. Now I had to remove a lot of stuff. Okay, so first piece of evidence is evidence of following an intentional removal of predators. Here, there are a number of studies by Stauffer, and most recently, those are studies that's been conducted by Dr. Sokolov and myself that showing these effects. I'm going to show you only one of them. I think you should go to the Sokolov et al. 2017, but I just want to acknowledge older literature that show that when you have higher density of predator fish of the snail, you have fewer snails and potentially less transmission of disease. And so snail-eating fishes have been, when being removed from system, for instance, from Lake Malawi, they've shown that, you know, they can control snails, and that so removing this predator has been associated with an increase of snail and increase of transmission. Okay, you remove the predator and you see more transmission. There is a second line of evidence that is related to the unintentional introduction of predators, and usually alien predators. And here I want to acknowledge and pay a tribute to two giants of this specific area of biological control of snail-borne trematode infection, Dr. Sam Locker of the University of New Mexico and Dr. Armand Couris from the University of California, Santa Barbara. In sorry for my voice. One of their seminal case has been following the natural invasion of an alien species in Kenya, the Procambarus clarkii, and its effect on the snail population in the water bodies where they started to find the Procambarus clarkii, and in places where the Procambarus clarkii had not invaded yet. And they provided strong evidence of effect of Procambarus clarkii on the snails that amplify schistosomiasis, but the effect on reinfection rate on population was a little bit more fuzzier, but it was there. So there is an evidence that predators can indeed control. Then there is a series of experiments that has been conducted in the lab. I just mentioned once. There is also Schwartz et al. 2016. This is from Sokolov et al. 2014. That it's a beautiful textbook example of how you run experiment by basically getting a number of snails of different body size and a number of prawns, freshwater prawns, the Macrobrachium volanovi or the Brachiobrachium rosenbergi, so the African and the Malaysian species respectively, and see how much each prawns eat of snails per unit time. And this paper, it really clearly showed that the basically predators, prawns, can control the snail that amplify the schistosomiasis disease. And now moving into modeling analysis, so mathematical analysis of prediction and control of schistosomiasis. Most of the studies that are presented here are collaborative studies that I myself spearhead in this project. I'm going to mention only once of that was led by Chris Hoover. This is a bioeconomic model of prawn aquaculture integrated with disease control, has been published in 2020 on as a nature sustainability as model effect of prawn aquaculture and poverty elevation on schistosomiasis control. This is an aquaculture productive model. We track basically somatic growth of Macrobrachium volanovi, the African freshwater species, and of Macrobrachium rosenbergi. We look at density-dependent mortality, and so what was the demographic rate in time. We identified what is the corresponding biomass here, and also look at the cost of management and what was the revenues harvesting basically the the stock after 6 months or 12 months or 18 months, and found basically this line that allow us to identify basically the optimal rotation time, the one that allow us to maximize the net profit as the sum of revenues minus the cost of management. And so we did this, we identified what is this optimal prawn density to begin with, what is the rotation time. We plug this into an epidemiological model of snail dynamics, and we basically found that the combination of medical treatment of people that is potentially infected with schistosoma parasites and the use of prawns in a profitable aquaculture whale in rice paddies, it's able actually to control the transmission of the disease. So we get what we call a win-win. It's a multiple win because it's an integrated agriculture. So it basically the farmer get his rice paddies, revenues from the rice paddy, which we get anyway. You get revenues from stoking the prawns and harvesting and selling on the market. And in addition, the farmer and his family, typically the kids that try to scare the bird away, do not get infected with schistosoma parasite. So it's a win-win-win from rice production, for prawn production, and for health. Let me go now to the fifth piece of control. It is control trial field experiment that we conducted in Senegal, a colleague conducted in Côte d'Ivoire, and I'm going to show you just a little bit of this information. So we're here in Western Africa, where we've been working for a year. We're in Senegal, in the lower basin of the Senegal River, where at the border with Mauritania. And here, in a few years, we follow nearly 1,500 school-age children that were tested and treated for schistosomiasis in 2016, 2017, and 2018. From 16 villages, 6 were on the river and 10 were on this lake, Lac de Gouyer. We originally meant to have 10 prawn villages and 6 control villages. And if you're an ecologist, or if you're interested to know more, I will not get into the detail, but we use a before-after control impact design. And the goal here were twofold: to do the domestication of the African river prawn, the Macrobrachium volenovi, and basically foster commercial production, and stock prawns in enclosures. So we build up with the net enclosures around the water access point, the place where people step into the water to fetch water for the daily chores. And we wanted to check basically what were their infection rates in those years. I think in this conference, it's relevant to mention that we build a commercial scale prawn hatchery. And when I say build, I should really refer to Nicolas Jouanard, who is the head of the Système Innovatif d'Aquaculture in Saint Louis, Senegal, a French entrepreneur and young scientist, and also Sean Coyle from Kentucky State University, and Ami Sagi, who will be cited again from Ben-Gurion University, who all contributed to this side of our venture on biological control of schistosomiasis. So this is a commercial scale aquaculture that used to be, in fact, an aquaculture hatchery to raise a Macrobrachium rotenbergi, which eventually we brought in Senegal. But in the first few years, we tried the domestication of Macrobrachium volenovi. We brought also Macrobrachium volenovi, either producing the hatchery or fish in the estuary in the ponds that the Ministry of Agriculture owns in the lower basin of the Senegal River. I just show you this earth pond of 1 hectare or 1/4 of a hectare where we stock prawns and we gather them to derive a number of biometric measures. And I want to acknowledge the Ministry of Agriculture and l'Agence Nationale d'Aquaculture and ANIDA for their support to this project. There is a lot to be said about this project, but I need, for the sake of time, just to keep it short. The results of this controlled trial experiment is that, well, we gathered a lot of incredible information on basically the biometrics of prawn growth and snail density and snail distribution. We have been able to show that snail density was lower in sites with more African prawns, which was good, but unfortunately, we were not able to discern statistically the effect of reinfestation rate in school-age children. And of course, why that happened. And we have several explanations. They're not mutually exclusive. Well, first of all, we had too few prawns at the end. We were not able to reach in 2 years the breakthrough in African prawn domestication. That was too much, was a little bit too ambitious. that's the truth. And so we ran out of prawns basically, and we had to fish prawns from the estuary because we had only a small production of prawn from the hatchery. Second point is certainly there is also too much year-to-year variability. There's very little to be done there except stocking a lot of prawns to try to see whether there is an effect, which we couldn't do for the reason that I just explained. And then prawn are also escape artists, and so enclosure, they were not able to keep them. And not only when we were trying to use better enclosures, smaller nets, the enclosures themselves modified water circulation, and along with water circulation, water quality. And that is the problem if we change water quality in a place where water, of course, is used for all the daily chores, including cooking and washing. And so there was a problem in the design. And if you have any idea how we can do it better there, you're welcome to contact me. So the conclusion that we need to use aquaculture species that are easier to produce or that are sturdier. Let me go now to the last piece of evidence. That is this, basically this is the slam dunk, as they say here in the United States, is the crystal clear evidence that basically you can use actually Microbrachium rosenbergi, the Malaysian species, to control parasitic infection in aquaculture. And here I want to say out loud that all the merit is for Professor Amir Sagi from the University of Ben Gurion of the Negev in Israel, and his amazing group, including Professor Aflano, Dr. Amit Savaya, Sharon Moscovich, and a number of other people. They develop, Amir Sagi developed a system to produce monosex Microbrachium rosenbergi that is only male or only female. So we can use these species also in countries where they are non-native without getting the risk of having an alien species taking over the local fauna. And they use for control of trematode infection in tilapia farm. And I strongly recommend you to look at Savaya et al. 2020 paper published on aquaculture last year. And in this specific case, because an image basically tells more than lots of other words and graph, you can see the difference in the abundance and density of snails above when you do not have prawns and below where they stock prawns. So Microbrachium monosex, Microbrachium rosenbergi, has been able in this experimental pond in the field to basically remove the vast majority of the snails that are presented there, which is fantastic. So let me go to the last point to mention that there is an army of enemies of our enemies, the snails that amplify parasites in aquaculture or the amplified parasites that are of public health importance. There is a paper that has been just published by Isabel Jones on People and Nature, a British journal, and explain 3 reasons why we should consider, basically natural enemies as biological control agent of human diseases. And I want to say that in addition to monosex rosenbergi, there are other species like Heterotis nicotylus of African catfish or the African langfish that are known to be snail eater, and they can be used to control the snails in this environment. I also want to say that there is a great potential for aquaculture for health. We have been studying basically business model to make it sustainable economically, and we're now currently doing this with an amazing group for the University of Stirling that is led by Dr. David Little and Dr. Roger Nolman, along with Reid Otzerich and Rachel Kumi in Côte d'Ivoire, through the Belmont Forum for Climate, Environment and Health. And these all together are what we call the 4 pillars of poverty alleviation, one health-based solution. So they're solutions that are good for increasing food production through aquaculture, that support small-scale business, so they fight poverty, they allow basically to control snail infestation and to have positive effect on public health. Conclusion: there is evidence of successful biological control, but this evidence is still limited. The challenges are formidable, but the potential and the promises remain high, so we still need to do more work in this direction. And in case you see a place to collaborate, please contact me. We can try to understand how to form partnership to try, to conduct this control trial experiment. We need more work to replicate original effort, in fact, with monosex prawn, fish, or other enemies in control trial design. And we need to use this system thinking approach to strive for win-win solution and target multiple sustainable development goals. And we have commented in this paper we published this year on how to identify win-win intervention that benefit human health and conservation. And if you're really interested, Google in protected by prawns. Okay, this is a video documentary that is being produced by the California Academy of Science through their biographics venture and website. So if you Google in protected by prawns, you will be directed here, and there is a beautiful documentary. It's only 10 minutes that show our work in Senegal. And with this, I want to thank you for your attention, and I'm ready to take a question if there is any, or if there is time. Now, do you know how? Oh, here. Okay. So this. Okay. So I should be back here, right? Okay. Perfect.
Thank you very much, Dr. Liu, and it was an interesting presentation. Any queries or any remarks?
I received some comment in the private chat, but Dr. Bichava, for instance, has to leave, so I'll reach out.
Okay, you have received some question, right?
Okay, yeah, and if there are no questions, that's okay. I mean, we are at the end of the time. I can stay here a couple of more minutes, but I'll leave at 3 p.m. London time.
Okay. So any queries? So if no, we will end the session of day 1.
Yeah, maybe Dr. Ghosh will have the time to show the video he wanted to show before.
Yeah. Dr. Anupam, do you want to show any video?
Oh, no, thank you very much, Dr. Leo. No, at this moment, I am unable to do this thing. Anyway, thank you for your offers.
Yeah, thank you very much, each and everyone, for your valuable presentations and your time for joining our event and making it a successful one on day 1. So I hope you all join on day 2 as well. So an important note, the presentation from Dr. Wilson Chira was rescheduled for tomorrow. He's having some internet issue, so confirm that he will join on day 2. The third presentation, oral presentation. Yeah, thank you very much. Have a nice day.
Bye-bye.
Bye-bye, everybody.
Bye-bye.
Bye-bye. Thank you.